So I'll start the session. Like today's lesson is work, power, energy. I hope that, in the main class, we have now finished up to Newton's laws. We have finished up to Newton's laws. And this Thursday and next Sunday, we'll be starting coplanar forces. And if there are any Sinhala medium students, you have a session tomorrow. And even the English medium students, if you find it hard to join today's session, you can join tomorrow's one. If there are anyone who have any other classes or anything like that, you have the option of joining tomorrow also. But tomorrow I'm teaching in Sinhala. That is the only difference, but with English terms and all. Okay. So, like today's lesson is work, power, energy, and like not related with many other lessons. So if you haven't done Newton's laws or like, anyways, everyone have finished. Like definitely everyone have finished motion, right? Everyone have definitely finished motion, and if you haven't done Newton's laws, I don't think that it will be a huge issue. We'll see about that. So. Okay. So. Let's start with the session. Uh, so talking about, pay attention everyone, pay attention. Talking about work, power, energy, like today we are talking about like until the end of Newton's laws, what we have discussed is, we have discussed about motion, right? How things happen. Then in motion we discussed like how we go from point A to point B, okay? We discussed how we go from point A to point B. Then after that, what we discussed was like who's behind this motion? Who's behind this motion? What decides how we go from A to B? What decides how we go from A to B? It's a force. Now, in this lesson, what we are going to discuss is what decides or who provides energy or the capacity or the power for this motion, okay, which is work, power, and energy. So in this session, we'll be starting with the term called work. Work. So what is work? What is work? I mean, anyways, like assume that if you are like, think that you are pushing a vehicle or a car or something, you are pushing a vehicle. After the process, you feel tired, right? After the process, you feel tired, right? What is the reason? What is the reason for that? What is the reason for that? The main reason for that is you pushing a vehicle definitely is a work, and work consumes energy, right? Work consumes energy, okay? So that is the main reason. Work consumes energy. So go to your tute. Hope all the online students got the tute too. Mali, provide the tute in the Zoom chat. Provide the tute in the Zoom chat. Then, when there is an when there is an external unbalanced force on something, when there is an external unbalanced force on something, we call that there's a possibility of motion, right? There's a possibility of motion. There's a possibility of motion if there's an external unbalanced force on a system. So this force has the capacity to create a work or do a work, right? To do a work. Then you have already learned the definition of work, right? You have already learned the definition of work. The definition of work is force into displacement that you had in O levels, right? Definition of work is if you are providing a force F on an object and due to that force, if this object obtains a displacement of x, due to that force, if the object obtains a displacement of x, the work done would be F into x, force into displacement, okay? Force into displacement, clear? But like this is how you learn that in O levels, right? This is how you learn that in O levels. But here the scenario is bit different, okay? Here the scenario is bit different. Like we are going to develop on this concept called work. In O levels it was just force into displacement. But if we properly explain that, it is force into the displacement of the point of action of the force. Clear? It is not just force into displacement, it is force into the displacement of the point of action of the force. Clear? Force into displacement of the point of action. It is a very crucial point because in all of us we didn't have that issue. You get the force, you get the displacement, you multiply them. That's all. But in A levels there may be scenarios like this. Okay. You have an object like this. You have an object like this. You push that with a force. Due to this force, it goes like this. It moves like this. Now if you consider the displacement of this point, it is x1. Displacement of this point, it is x2. Displacement of this point, it is x3. See? Okay? If it is not a uniform motion, okay? If it is not a proper uniform motion, different points would have different displacements, right? Different points would have different displacements. Clear? But what matters is the displacement of the point of action according to the proper equation. Clear? What matters is the displacement of the point of action. And again, a further improvement to the definition. It should be the force into the displacement of the point of action in the direction of the force. In the direction of the force. That means if you are providing a force in this direction, if the displacement happens in this direction, for an example, assume that you have an object like this. You provide a force like this. You provide a force like this. And assume that this angle is theta. Now, due to this force, the object will move like this. The object will move like this. In this case, the whole force didn't participate in the motion, right? In this case, the whole force wasn't able to participate in the full work, right? Why? You are providing the force in this direction, but it is moving in this direction. Clear? So in that case, you have to get the force component in this direction and multiply it by the, so this is the displacement of the point of action. This is the displacement of the point of action. Clear? So in this case, you either multiply the displacement by the component of the force in this direction, or you multiply force by the component of the displacement in this direction. Clear? Okay. For maths people, you are actually getting the dot product between the force and the displacement. Okay. For maths people, you are actually getting the dot product. Okay. You are actually getting the dot product. Okay. That's why fx cos theta you are going to get. Okay. It's a different story. We don't have to think about that here. So what actually happens is you multiply everything in the same direction. That means in this case, if you need to get the work, what you do is you get f cos theta because the displacement is in this direction. So you get the force component in that direction, f cos theta, f cos theta into x, Because actually what happens is this is f cos theta, this is f cos theta, and this is f sin theta. Here f sin theta isn't doing any useful work, right? Here f sin theta isn't doing any useful work. Clear? It's not doing anything useful, right? Because it's a downward force, okay? It's a downward force and it's doing nothing here. Clear? Only the horizontal force participates in the work. Clear? Got the idea? And the work, as usual, in joules, measured in joules, and it's a scalar. It's a scalar quantity. Okay? It's not a vector, it's a scalar. Okay? So, let's start with few questions. Go to exercise 1. Go to exercise 1. Do question 1. 2, 4, and 5. 1, 2, 4, and 5. You can find the tut in the Zoom chat. You can find the tut on the Zoom chat. If not, let us know. And again, you should put the tut in the WhatsApp group too. You can find the tut in the WhatsApp groups too. You can find the tut on all the WhatsApp groups. If you can't find the tut, put a message to this number, not 701546825. And anyways, class students, if you need to get the tuts delivered, okay, contact this number, okay. Put a message to this number if you need to get the tuts delivered, okay. Put a message to this number, not 701546825. Now also, if you can't find the tutor, if there's any kind of issue as such, uh, put a message to this number. Like these are just from your O-level content, okay? And others, if you're done with these questions, try to finish the exercise, okay? Exercise 1. Exercise 1. Like when you're putting a message, mention your class and mention your year of A-level and the tute you need, okay? Otherwise, we don't know the... And your assessment will send you a form to fill anyways, but send the message with those numbers, then we know which tutes you need. So the definition is force into displacement. Force into displacement. So the first question, quite easy. You're applying 20 newtons. You're applying 20 newtons, and under this 20 newtons, there's a displacement of 4 meters. So the work is force into displacement. Work is force into displacement. Here force is 20 newtons. Here force is 20 newtons. And displacement is 4 meters. You will get a work of 80 joules. You'll get a work of 80 joules. Then in the second one, you are applying a force like this of 8 newtons, and the displacement is in this direction. Displacement is in this direction, 2 meters. So you have to get the component of force in that direction. You have to get the component of force in that direction first. So when you're writing the work, you write 8 cos 60, 8 cos 60, 8 cos 60. The force in that direction, 8 cos 60. into the displacement, which is 2, then you get 8. Cos 60 means half into 2, cancel out, you get work of 8 joules. You get a work of 8 joules. If we do the fourth question, this is the object. You have 6 newtons like this. You have 6 newtons like this. The angle is 30. The angle is 30. 5 newtons downward. 5 newtons downward. 4 newtons horizontal. 4 newtons horizontal. Then it is moving 8 meters in this direction. Then it is moving 8 meters in this direction. Clear? So, if I have to write the work here, first thing is displacement is in this direction. Clear? So, only the forces acting in this direction will participate in this work, right? Only the forces acting in that direction, clear? Only the forces acting in that direction will participate on the work, right? Clear? Only they will participate on the work. So you should find all the force components only in this direction, clear? So that means you get a 6 cos 30 in that direction. 6 cos 30. You have 6 cos 30 component in this direction. 6 cos 30 component in that direction. Plus 4 newtons in this direction. And for 5 newtons, there is no horizontal component. It is entirely vertical, right? 5 newtons is entirely vertical. There's no horizontal component. So only 4 and 6 cos 30 participate in this work because the displacement is in this direction. Displacement is in this direction. So you write 6 cos 30. Cos 30 means root 3 over 2. Cos 30 is root 3 over 2 plus 4 into 8 joules. Into 8 joules. Clear? And today I will provide all the past paper discussion recordings again for you guys. Like, I mean, not actually past papers, term test paper discussions. So what I need you to do is watch all those term test paper discussions. As I mentioned, like I actually didn't mention this in the Thursday class. Don't go for the first term test without actually doing at least 5, 6 or 10, 15 term test papers, okay? Because you know physics, but you will find hard to match your physics with, the term test paper, because it is just a paragraph with bunch of information. Now you have to match the information with the theory you know, okay? It's a bit difficult task, okay? So what I need you to do is just keep trying some term test papers, okay? keep trying some term test papers. And yesterday also, not yesterday, the day before yesterday, I provided 4 more term test papers translated, one from Ananda College, one from Vishaka, and another bunch of Lyceum papers, and different school papers are now being translated. I'll provide everything in the group. What I need you to do is try them, and most probably next week I'll do the, I mean, this week we were not able to, last week we were not able to do the past term test paper discussions, right? This week we'll be starting that again, and this Friday and also next week I'll do a bunch of extra classes to discuss some term test papers and to like make sure that your content is ready for the term test, okay? So what I need you to do from your side is just practice as much as possible, okay? Practice as much as possible. Uh, like do all the term test papers, watch the term test paper discussion recordings. Everything is available now at the website, okay? Go through all the content and try to be comfortable with the physics, but not only physics. Try to build the ability to applying your physics into a content in the paragraph, okay? Okay? Because we did past paper discussions yesterday and last Thursday also. You should understand the in the past paper, they don't mention which physics to use. It's just a paragraph. Now you have to figure out from the physics you know which physics to use for the each part of the paragraph, right? Okay, question is just a paragraph. Okay, it's not like, it's not simple like we teach friction, we give a question from friction. We teach vertical projectiles, we give a question from vertical projectiles. It's not simple like that. They don't mention the physics you have to use. It's just a paragraph. Now you have to use your knowledge to decode all the information in that paragraph, okay? So like practice as much as possible. Okay. So let's continue. And for private school students, one of the main issues they had was rotational motion. I discussed that last Friday. We did a 6-hour session. Normal class students don't have to watch that. Okay, it's just a quick revision of all the rotational motion content in 6 hours to like make sure you're okay for the term test. And if there's enough students who are getting hydrostatics and hydrodynamics too, I can do a session for that also, okay? Just let me know, okay? And all the other small parts that you are getting for your term test, let me know. I'll try to cover them up, okay? Let's try to do it that way. Okay. Let's go to question 8. Let's go to question 8. Go to question 8. An object of mass 5 kilogram is placed on a smooth plane inclined at 30 degrees to the horizontal. Calculate the work done by gravity when the object moves a distance of 5 meters along the plane. Okay, again. Try question 8 quickly. Try to get the answer for question 8. Go to question 8. And someone asked question 5 too. I'll do that while others are trying question 8. I'll do question 5 while others are trying question 8. It is 30 degrees inclined plane, 30 degrees inclined plane, and you have the object here. You have the object here. You are applying a force of 100 newtons. You are applying a force of 100 newtons. And it is moving 6 meters under this force. So here both force and displacement is in the same direction, so no worries here, right? Here both force and the displacement is in the same direction. Both force and the displacement is in the same direction. Clear? You have the force and the displacement in the same direction, so no worries. Force into displacement gives you force 100, and the displacement is 6 meters. Force 100 and the displacement is 6 meters. So you will get here 600 joules. 600 joules. You'll get here 600 joules. Go to question 8. It's just the force multiplied by the displacement in that direction. And like while you are trying those questions, like take a piece of paper and try. I'll give some additional questions too from motion and all. If you have time in between the exercises and theory and all, just try these questions. Some like not difficult, some nice questions actually. Like write them in a separate piece of paper, and like in the class, if you have some additional time between questions and theory, just try to get the answers and give me the answer, and I'll check that. The question is, I think I gave this in one of the classes. We throw something vertically upward. Pay attention, everyone. Write down the question. This is not related to work power energy, but in between these questions, if you have some additional time, try them, okay? Try them. I do a vertical projectile. With a certain velocity. This is the displacement time curve. This is the displacement time curve from a certain point. This is the displacement time curve from a certain point, okay? This is the displacement time curve from a certain point given in the graph. Displacement time curve from a certain point. The values are here 6 root 5, here 6 root 5, here 10, here 10, and here 6. Here 6. That means this is the displacement time. So when I project this upward, it goes up and falls down. It goes up and falls down. This is the displacement time curve relative to a certain point, okay? This is a displacement time curve relative to a certain point, okay? They are not mentioning the point, okay? They are not mentioning the point, okay? It may be a point here, point here, point here, somewhere. This is the displacement time curve relative to a certain point. They need you to find the projectile velocity, velocity of projection. Write this down and try to get the answers in between theory points, okay? An additional question, try them only like if you have enough time, okay? Others, try question 8. Try question 8. And just tell me the answer, okay? Just tell me the answer if you get the answer. I do a vertical projectile with a velocity v. It returns to the same point. This is the displacement time curve of that object relative to a certain point. Displacement from a certain point with time. They need you to find the projectile velocity. Projectile velocity. Go to question 8. If you are done with 8, try 9. I won't do all the questions, okay? I'll provide an answer script for this, okay? But keep trying and try to finish the whole exercise within the given time in the class. Then you have nothing else to go home and do. I'll provide you a past paper, tute and all in the group. You can try them at home. Try to finish the exercise in the class if you have time. Question 8. Question 8. The angle is 30. The angle is 30. The weight of the object is 50 newtons. Weight of the object is 50 newtons. If this is 30, we know that this is 90, then this is 60. If that is 60, this becomes 30 again, right? This becomes 30 again. If this is 30, this is 30. Now they are asking the work done by gravity. Work done by the gravity means the gravitational work done by the gravitational force, right? Work done by the gravity means gravitational force. Gravitational force means weight, right? What is gravitational force? It is the weight, right? Weight is the force produced by gravity, right? So what they're actually asking is the work done by the weight. Work done by the gravity means work done by the gravitational force. What is gravitational force? It is the weight, right? So again, displacement is in this direction. Displacement is in this direction, 5 meters. So we have to get the force component in this direction. The component in this direction have nothing to do with the work. We need to get the force component in the direction of displacement, which is 50 sine 30, which is 50 sine 30. It is 50 sine 30. 50, you have sine 30 in this direction. So what is the work done? What is the work done? Work is Fx, force into displacement. Force into displacement. And again, like we started giving essay questions in your papers, right? We started giving essay questions on your weekly papers. Now, like you lost some marks for few, like even in the first paper, like because you didn't write the proper steps, okay? So what I need you to do is, even when you are doing, I mean you get one paper per week, right? You can't use a bunch of papers for that. When you're writing answers, okay? When you're writing answers, I taught you the proper format of a A-level marking scheme, right? So when you're writing answers, even for random exercises like this, try to follow that order. Try to follow that order. Try to write according to the proper A-level marking scheme. Then you don't have to do the practice on your weekly paper. You can directly write proper answers in the proper format in your weekly paper, okay? So use the exercises to, still for every step I write W equals Fx. Why? There's 1 mark always allocated for the equation, okay? Like that, when you are doing random exercises in the tute, do practice the format to get marks on your essay papers, okay? This is very crucial for the term test too. You don't write the proper steps, you have the final answers, you will get only 50% of the marks, okay? More than around 70% of the marks are allocated for the steps. Actually, 10% is allocated for the proper units, and 20% is usually allocated for the final answers. So if you are a person who skip many steps and you get only the final answer properly, you will get only 20 marks, okay, out of 100, okay? So steps matters, but you can't use the weekly paper every week for that, okay? It's a lot of trouble then, okay? It's a lot of trouble, okay, because you get only 1 paper per week as a class paper. So when you are doing random exercises like this, just try to follow the proper order, okay? That's what you should do. So work equals Fx. So what is the force in this direction? 50 sine 30. Force is 50 sine 30. Force is 50 sine 30. 50 sine 30 multiplied by displacement. Multiplied by displacement. 50 sine 30 multiplied by the displacement. Force into displacement. You get 50 sine 30 means half. Sine 30 means half into 5. Into 5. Okay. 50 over 2 you get 25 into 5, 125 joules. 125 joules. 125 joules. සීතලයි කියලා කියලා තියෙනවා සීතල කට්ටිය අත උස්සන්න. පොඩ්ඩක් මට AC මොන හරියද? තව කවුද සීතල කට්ටිය? මේ හරියට සීතලද? Anyone else? Okay. And like, yeah, a small correction actually for this one. Consider this as a distance time graph. Consider this as a distance time graph because the direction may change a bit. So consider this as a distance time graph. This is a distance time graph. Not a displacement time graph, it's a distance time graph. Okay, again, pay attention. If the work is given by force into displacement, what would you get? Pay attention, stop talking. What would you get by the area of a force displacement curve? If the work is given by the area of a force displacement graph, okay, force displacement graph, sorry, if the work is given by force into displacement, what would you get by the area of a force displacement curve? It provides the continuous multiplication between f and x, right? It provides you the continuous multiplication between f and x, clear? Which means the overall work, clear? Which means the overall work, right? That means it provides the overall work, clear? So in exercise 2, you have a bunch of graphs given, okay? You have a bunch of graphs given. You can find the area, right? You don't need me to teach that, right? Okay? So just find the area and get the work, okay? Just find the area and get the work. Okay? So I'm not going to do exercise 2. Just find the area and get the work. But there are, pay attention, there are some additional points to mention about work, okay? Usually, work is a scalar, right? Pay attention. Work is a scalar, right? Okay. So when it comes to scalars, we only have positive values, right? There's no positive and negative in scalars, right? But when you consider work, it has positive and negative, okay? Usually for scalars, you don't have positive and negative, but work is still a scalar, but it has a positive and a negative. Why is that? What is the reason? What is the reason? Because when an object moves in this direction with a certain velocity, if you provide a force like this, and if the displacement is in this direction, you are actually supporting this motion, right? You are actually supporting this motion. As a result, the velocity will increase. As a result, the velocity will increase, clear? But if there's an object like this still moving with a velocity v, and if it moves a distance of x under a force like this, you are actually not supporting the motion, you are against the motion, right? You are actually not supporting the motion, you are against the motion, clear? As a result, the velocity will decrease, right? Velocity will decrease, clear? Here the velocity will increase. V1 is larger than V. Here the velocity will decrease. V2 is smaller than V. Clear? V2 is smaller than V. Clear? So as a result, this supports the motion. So this we call a positive work. This we call a positive work. Clear? Positive work. Here it's against the motion. It's not supporting, it's against the motion. Clear? This kind of a work we call that a negative work. Clear? A negative work. So how are you going to find ideally whether it's a positive work or a negative work? If the force and displacement is in the same direction, it's a positive work. Here the work is Fx. If the force and displacement are in opposite directions, clear? If the force and displacement are in opposite directions, we call that a negative work. Clear? So this is a scalar, but still it has a negative value. Okay, these kind of stuff are really important when it comes to A levels. Okay, it's really important when it comes to A levels. There are like equation questions. For when it is today A level started. Okay, so when it comes to A level students, the people who are really close to A levels, again one of the main parts they find hard is these equation MCQs. That means you have a bunch of equations in the MCQ and they are asking you to choose the correct equations. Because in those equation questions, they check very crucial theory points, okay? Like this, they give a random, line like this. Only vectors have positive and negative values. Ideally true, right? In many cases, in 99% of the scenarios, it's true. Only vectors can get positive and negative values. Ideally true statement, right? Okay, but there's one scenario when it comes to work, which is a scalar. It is still a scalar but has positive and negative. Clear? So these kind of points, they never ask you like, can work be negative? Okay, it's definitely you know the answer, right? These kind of small theory parts appear in those paragraph questions, small paragraph questions and theory related MCQ questions, okay? There they check because it's a very, 99% of the scenarios only vectors have positive and negative. There are only few scenarios that scalars have positive and negative, okay? Clear? Okay. This is one of the scenarios. Okay. Again, like the perpendicular forces will never provide a work on a system, right? That also you know, right? A perpendicular force will never provide a work on a system, clear? It will never do a work on a system, clear? Why? A perpendicular force won't have a component in this direction, right? Okay? A perpendicular force will never do a work, clear? Now, pay attention, pay attention. Next main thing is, now we know the definition of work. Work is someone doing something, right? Work means someone doing something. Who provides the ability to do work? Pay attention. Who provides the ability to do work? energy. Energy provides the ability to do work. Okay. And what is energy? Energy is actually a constant when we consider the universe. Okay. It's actually a constant. I mean, ideally in our syllabus it's a constant until the last lesson, because when we meet nuclear related stuff. Okay. When we meet nuclear related stuff, uh, all of a sudden energy isn't a constant anymore. Okay. It's a different story. In nuclear science, energy can be converted into mass, mass can be converted into energy. That's the whole point of nuclear science, right? You convert a mass, you destroy a mass, certain mass, into energy. But when we forget nuclear science, okay, when we forget the nuclear part and all the nuclear equations, usually energy is a constant in the universe, okay? Usually energy is a constant. So, ideally, when we consider the earth, what is the main source of energy? Usually in our syllabus, we consider sun as the only source of energy, but it's not actually the only source. We have a heated core. Earth has a heated core which has the ability to produce energy, but we are not still harvesting that properly. Okay? We are still not harvesting that properly. Or else we have a heated core which we can use for energy. But when we forget that, still like all the useful energy we get from sun. Okay? All the energy types we see, they are produced by sun. Why? Like you start from like sun will provide the required stuff to trees to grow, right? Trees to grow and like bear fruit and all. Sun provides the required energy and all, right? Sun provides the required energy and all. Then it continues, okay? Then it continues. This produce something, and different animals eat this, okay? And it continues, and we human also eat either this or some animals, okay? Then we continue to die, okay? We continue to die, okay? Then we and all other dead stuff turns into fossil fuel. After years, everything turns into fossil fuel, okay? We bring this fuel, and use this in diesel power plants, petroleum power plants, and all the power plants we use this, okay? We use this in all the power plants. And again, this produce current. This current energy is used at our homes for everything else, okay? Then this produce some wastage. Again, go back to the nature, turns into carbon, some amount of carbon. This wastage turns into carbon. The carbon again absorbed by the trees to a certain level, like that, okay? So the whole process was started by the sun, right? Not only this, even the other alternating energies, like, what are the other alternative energies? Like wind, result of sun. Why? Due to sun, some areas heats up a lot. Some areas heats up a little. So when the temperature goes up in this area, the gas expands, the atmosphere expands. Then the density of this area decreases. Then in cooler areas, you have high density gas. This high density gas will come to replace this, right? When you are when you consider liquids, high density stuff will always go down and low density stuff would come up, right? So here also, if the temperature of a certain area is high, the gas in that area, atmospheric air in that area will expand and the density will decrease. This will go up. and it will be replaced by cooler air. This is wind. This is wind. Okay? This is wind. And due to wind, all the sea waves and tides forms, all the types of energies, okay, we consider, okay, all the types of energies are produced by sun, ideally by sun. Clear? So when it comes to today's, like today's technology and all, like we can call our main or the only energy source is sun. We are not harvesting the energy from our core properly yet. Okay? Then, and again, like even the things like this, okay? Pay attention. Even the things like this, I mean, take this pencil. This contains a lot of energy, okay? This contains a lot of energy. I mean, that's when the nuclear science come to play. That means, I mean, yes, this contains energy if I throw this at someone, but that's not the case. That's not the case. This contains a lot of atomic energy. This contains a lot of atomic energy. So if I have the capacity, to turn this whole mass into energy, okay, still the nuclear power plants are also unable to do that. We are not converting mass into energy at 100% efficiency. If I can convert the energy of this pencil into 100% energy, I mean this will be able to power the whole country for like few days, okay? Not few days, maybe few years, okay? It contains that much of energy, okay? You can remember that, right? Einstein's famous equation, E equals mc squared. Have you heard this? E equals mc squared. Mass converted into energy. We are not going to discuss this stuff in this lesson. We'll be discussing this in matter and radiation lesson, last lesson, okay? But I'll be doing a seminar for matter and radiation too because for the 26th batch, some students are writing nuclear science Olympiad on January. If there are some interested students here too who need to write nuclear science Olympiad, will be on January. Just let me know. I'll provide you at least the recordings of matter and radiation, okay? So it's a different story. We are not going to discuss Einstein physics or nuclear physics here. We'll be doing that in the last lesson. Pay attention. Pay attention, everyone. In this lesson, stop talking, everyone. In this lesson, what we are concerned is, okay, in this lesson, what we are concerned is about the mechanical energy, not all the types of energies. You have nuclear energy, optical energy, heat energy, sound energy, chemical energy. There are thousands of types of energies, but in this lesson we are focusing on mechanical energy. What is mechanical energy? Mechanical energy is two types of energies: kinetic energy and potential energy. Mechanical energy is a sum of two types of energies. One is kinetic energy and the other one is potential energy. Clear? This is mechanical energy. Okay? This is mechanical energy. So here, okay? So here, in the lesson, we'll be learning two types of kinetic energies. Linear kinetic energy. Linear kinetic energy means the energy of an object due to the linear velocities, half mv squared. This is linear kinetic energy. And the rotating objects would have rotational kinetic energy. We'll be discussing this in the rotational motion lesson, okay? Rotating objects would have rotational kinetic energy. Clear? They would have rotational kinetic energy. Clear? Then again, the main two types of potential energy we'll be discussing would be, one is gravitational potential energy. One is gravitational potential energy. It takes some energy for me to lift this from here to here, right? It takes some energy for me to lift this from here to here, okay? Because when you move something up, it turns into gravitational potential energy, mgh. You have learned in O levels, mgh. So gravitational potential energy. And the other potential energy is also a new thing, elastic potential energy. What is elastic potential energy? Like when you compress a spring, it has the ability to do a work, right? If you release that, it will move like this, right? That means when you compress a spring, it has an ability to do work. And ability to do work means always energy, right? Ability to do work means energy, right? Clear? So that is elastic potential energy. Clear? Elastic potential energy. It's not only about springs, any object. The energy stored in an object due to the deformation of shape is elastic potential energy. Clear? Energy stored in an object due to the deformation of shape. Due to the deformation of shape is elastic potential energy. Even this pencil, okay, to a certain level, if I bend this, it will try to return to the initial state, right? If I bend this, it will try to return to the initial stage. Why? When I bend this, it stores some elastic potential energy, okay, which later when I release that will turn into kinetic energy, okay. That is elastic potential energy. We'll be discussing that properly in the lesson, okay. We'll discuss that properly in the lesson. We'll take one by one. We'll discuss kinetic energy. Then we'll discuss potential energy like that. Let's move forward with different forces. So I'll skip energy conservation for now. I'll return to that again. So go to your tute. You have different energy types, starting with kinetic energy. So rotational kinetic energy part, pay attention. Rotational kinetic energy is half I omega squared, which we don't have to consider now. We'll be learning this in rotational motion. In this lesson, what matters is the linear kinetic energy, okay? Go to exercise 3. Go to exercise 3. Do exercise question 1. Question 2. Question 5. And question 7. For that question given on the board, I received some correct answers from the physical class students. The answers were correct. And I'll put that question 15 too. I can remember the model paper number, model paper 47 or something like that. It was given in the Sunday class model paper. Was given in the Sunday class model paper. Try that one too. It is a very nice question. I'll try to discuss that today, or else I'll provide the recordings today by today evening, because we missed some question 15s from Sunday class. Thursday, I think I did everything. We missed some model paper question 15s on the Sunday class. So I'll discuss them too. But Thursday class students also, I think many students here are Thursday class students. So you also try this question. It's a nice question. There's a log. Sunday class students confirm the question. Confirm the question. I can't remember the question actually. It was, I think, model paper 47, question 15. There's a log with a radius r. There's a log with a radius r. I think the only question we asked was, there's a frog in this side. It can jump with a velocity of u in any direction it like. What is the minimum velocity required to jump to this side, right? That was the question, right? As I remember, that's all, right? That's all, right? In the question, I think that's all. If anyone have the paper, check, okay? That's all. That's the only data given in the question. They haven't mentioned the angle. They haven't mentioned anything. There's a log with radius r. There's a log with radius r. There's a log with radius r. What should be the minimum velocity to jump from this side to that side? That's all in that question. So the students who got the proper answer for the first question, try this. I'm giving these questions only to try when you're done with these questions, okay? If you're okay with theory, if you're okay with all the exercise questions we are doing, if you have time left, try these questions. Tell me the answer. And I'll either discuss all these questions by the end of today's session, or I'll provide the recording, I think by tomorrow. I'll be able to provide all the recordings by tomorrow of these small questions. These are not related to work power energy, okay? And this is a very famous question, okay? This is a very famous question. Others? Exercise 3, question 1, 2, 5, and 7. some students ask about this question. The best point is not this, okay? There are far better points than this, okay? This is not the best jump you can obtain, okay? This is not the best jump you can obtain. Exercise 3, question 1. A 4 kilogram object moves with a velocity 2, 5, 10. What is the kinetic energy? I'll do only one. Kinetic energy equals half mv squared. Half m mass 4 kilogram, 4 kilogram, velocity 2 meters per second. Velocity 2 meters per second. Velocity 2 meters per second. Half m v squared, 2 meters per second. So you get 2 into 2 squared, which means 8 joules. 8 joules. Question 2. 6 kilogram object traveling with a velocity 10 hits a wall and bounces with velocity 8. What is the energy lost from the collision? So a 6 kilogram object moves with a velocity of 10, hits and return with a velocity of 8. So the energy difference is the energy loss. Delta kinetic energy, difference in kinetic energy, half m v2 squared minus half m v1 squared. So you get half m v2 squared minus v1 squared, half, what is the mass? The mass of the object is 6 kilograms. 6 kilograms. Velocity difference is 10 and 8, right? Velocity difference is 10 and 8. 10 squared minus 8 squared. 10 squared minus 8 squared. Okay, so you get 6 over 2, 3. Here, 10 minus 8, 10 plus 8. 3 into 2 into 18. 18. What do you get when you solve this? Hundred and 8, right? No? Yes, right? 108. I mean, many of you guys can do this better than me, okay? Many of you guys can do this better than me because I mean, I lived 5 years with the calculator at the university. So now I'm not good at doing calculations, but whenever possible, just try to do as much, I mean, as many calculations as possible in your mind, okay, without writing, okay? Don't try to write all the calculations and do them, at least when you're doing exercises. Why? There's nothing to lose if you get the wrong answer here, right? Okay, so at least when you're doing the exercises, try to get as many answers as possible without writing. Okay. The main reason is I mentioned this in the first and second days of the class too. It's not because of the calculation to build the calculation ability. It's mainly to build the short-term memory. Okay, a better short-term memory. Why? Okay, you can think, okay, half 6, 10 squared minus 8 squared, which means 3 into 10 squared minus 8 squared, which means 10 minus 8, 10 plus 8, which gives me 2. 2 into 3 gives me 6. So it is 6 into 18. 6 into 18, if I try to calculate in a better way, I can get it as 12 into 9. 6 into 18 means 12 into 9. Okay. 6 into 18 is 12 into 9. So 12 into 9, you can easily calculate, right? It is 90 plus 18. 90 plus 18. Okay. Like that, I mean, create your own route of calculation. Okay. In your mind. I mean, what I recommend is you stop here and you try to write the answer. Okay. You stop here and you try to write the answer. Don't go through these steps. That is possible. Definitely, the only reason I'm not doing it in the class and I'm using the calculator is now I'm not good at that. Okay. Okay, my ability has gone. Okay. Because I used the calculator for 5 years at the university. Now I don't have that ability. And I'm too lazy to do that again. Okay. So, but you definitely try. It's not because of to build the calculation skills. It's mainly to build your short-term memory. You can create on your route of calculations. You can perform your own process of thinking without writing. That means you have to go from point A to point B in something. This is a certain thinking process without writing. So you have to store something in your mind, do another calculation, bring the stored value, multiply them, store it there, bring another value, multiply them. Like that you have to go through it's a nice exercise for your short-term memory, okay? That's why. You stop here, okay, 6 over 2, 3. Then 18 minus 8, 18 plus 8. 10 minus 8, 10 plus 8, which means 2 into 18, 2 into 18. 2 into 3, 6. 6 into 18. 6 into 18, if I think a better way, I can consider it as 12 into 9. Now this, you can get the final answer, okay? So it's a small mental process you are performing without writing a letter, okay? Okay, it strengthens your short-term memory a lot, and short-term memory is very crucial when it comes to A-levels because you haven't seen questions like that yet. You should see some recent A-level papers, okay? Just go through some recent A-level papers. You have the question in the first page. That means a huge paragraph in the first page. And the questions are asked in the next page. Sometimes you have a huge paragraph of 1.5 pages, and the questions are asked after that. So 2 whole pages, you have one essay question. It's a bunch of content to remember. Okay? Each time you need the information, you can't read the paragraph, okay? Each time you need an information, you can't go through the paragraph again. You should have a very good short-term memory, okay? Okay? So try to do that, okay? And at the end of the day, if you get the wrong answer, there's nothing to lose here. In the term test, I'm not asking you to get that risk, okay? Do the calculations the way you like in term test, but here nothing to lose, right? So try to do as many calculations as possible without writing a letter, okay? When the momentum of a given object is doubled, tripled, and quadrupled, by what half, actually by what ratio, will the kinetic energy of the object change? How can you do that? You know the momentum, right? What is momentum? Momentum is mv, mass into velocity. Momentum is mass into velocity. I mean, for a question like this, okay? For a question like this, they have asked the answer when it is doubled, tripled, quadrupled. I mean, without doing all three parts separately, it's easy to create an equation first, okay? Even when you are writing essay papers, okay, if they are asking the same thing again and again and again, okay, don't do the calculations for everything. If they are asking the same thing with different small changes again and again, ideally what I recommend is create a fundamental equation first, create a fundamental equation first, then do the calculations, okay? Which means, which means uh, I'll create a connection between the kinetic energy and momentum. It's easy, right? They're asking what happens to the kinetic energy when you change the momentum, right? Okay, so it's easy to create a relationship between kinetic energy and momentum first. Otherwise, you have to do calculation separately. You first consider that the momentum was doubled, then you get the change of velocity, then you put the change of velocity into kinetic energy. It's a lot of work, right? Okay, clear? You first think, okay, momentum was double. Then what happens to the velocity? Then you get that velocity and you check the change happened to the kinetic energy, okay? Other than that, it's easy to create an equation, right? How? I need v squared somehow, right? So I'll multiply, I'll get p squared, momentum squared. I will get m squared, v squared. I'll divide this by 2m. I'll divide both sides by 2m. I get the square of both sides and divide both sides by 2m, which gives me p squared over 2m equals m and m cancels out, half mv squared, which means kinetic energy, which means kinetic energy. Clear? So the kinetic energy is momentum squared over 2m. Momentum squared over 2m. Now you know what happens when the momentum is doubled. What happens to the kinetic energy when momentum is doubled? This is initial kinetic energy. For new kinetic energy, I'll consider it as kinetic energy 1. Only the momentum is doubled. Only the momentum is doubled and the mass doesn't change of an object, okay? When you consider a single object, mass does not change, right? So momentum becomes 2p. Clear? Then you get 2 squared means 4 into p squared over 2m. So that means you get 4 into, what is p squared over 2m? Kinetic energy. Clear? P squared over 2m gives you kinetic energy. 4 into kinetic energy. So new kinetic energy is 4 times the previous kinetic energy. Now you can easily get what happens when tripled, what happens when quadrupled. Okay, so when you start doing a essay paper, scan through the paper, and if they are asking the same thing again and again and again, okay, don't try to do calculations separately. First create a relationship, okay? First create a relationship, then use that relationship to get the answers, okay? Like this, we have to learn very small stuff to master writing a paper, okay? At the end of the day, how you write the paper, okay? I mean, if we consider the people who went for the A levels today, I mean, many of the 25 batch students are writing 6, 7 questions, okay? They need to write 4. They have more than enough time in A level paper. So they usually write at least 6 questions in the A level paper. They need to only write 4, but they will finish like, usually the 3-hour essay paper, they finish within like 1.5 hours. Because small, like small things that you upgrade like this. The way you thinking, the way you write, the short methods you use, when they combine and when they are applied to all the questions in a paper, it saves a lot of time. Okay, it saves a lot of time. Okay, so like try to optimize every small thing. Okay, your writing speed, whether you are writing it neatly. Okay, your writing speed, how you approach a question, the things you do to make it easy to do, get the answer. Even for an exercise like this, try to do that. Why? Try to be lazy and try to get the thing done using a minimum effort. Have that, have that view when you are always doing even exercises. Okay, even when you are doing exercises, try to come up with the answers, try to finish the exercise with minimum effort. So instead of doing things again and again, you create a fundamental equation for that. That that personality of the trying to optimize everything will help you a lot in A levels. Okay, okay. So it's just a combination of very small skills. Okay, you have to optimize every small thing. Writing speed, how you write, the pen you are choosing to write, everything, every small thing you have to optimize. Okay, that's how you perform very well in A levels. Okay, okay. Tripled, what happens now? Relationship between the kinetic energy and momentum. Kinetic energy equals p squared over 2m. P becomes 3p for new kinetic energy. For new kinetic energy, P becomes 3p. Then you get 3p squared over 2m. 3p squared over 2m. P becomes 3p. Then you get 3 squared means 9. Again, p squared over 2m. What is p squared over 2m? Original kinetic energy. So it is 9 times the original kinetic energy. Clear? It's 9 times the original kinetic energy. Let's go to question 7. Let's go to question 7. And if you're done with 7, go to 8. And if you have additional time, try those questions given on the board. And someone asked about the tomorrow's seminar. If you join today's session, don't join tomorrow's one. Okay, it's the same thing. Okay, it's the same thing. The students who can't join today and other students and Sinhala medium students, English medium students who were not able to join today, they will be joining tomorrow, not you. Okay, so if you are joining today's session, don't join tomorrow's session. If we need another session, I'll let you know. Okay, if I think we'll be able to finish work power energy today. Okay, then next week if I'm doing another class, it will be maybe a term test discussion, term test paper discussion, or some kind of a revision or something like that. Okay, and try to finish the friction tute given. Okay, try to finish the friction tute given. Next week you'll get another tute with all the questions from Newton's laws lesson. Okay, before that, try to finish the friction tute. I'll do a question discussion for the friction tute. Question 7. What is the velocity of an object that starts at rest when it is moved a distance of 5 meters by applying a force of 5 newtons? A break. Are we having 2 breaks or 1 break? The session is until 2. How many hours from 8 to... So 1 break would be enough, right? We'll think. I'll think. I'll think and let you know. I mean, get used to this, okay? Get used to this. You should have the ability to work for like 8 hours continuously if you are planning to do A levels. What is the velocity of an object? And at the end of the day, you are sitting and peacefully listening. I'm the one who's teaching, so I should decide when to get the break. What is the velocity of an object that starts at rest when it is moved a distance of 5 meters by applying a force of 5 newtons? You apply a force of 5 newtons. You apply a force of 5 newtons, moved a distance of 5 meters, moved a distance of 5 meters, starting velocity 0. What is the new velocity? So this is the idea. Here, the velocity increases due to the work done by me, right? Pay attention. Velocity increases due to the work done by me, right? Clear? That means here work done converts into the change in kinetic energy, right? Change in kinetic energy happens due to the work done, right? Due to the work done. Clear? So what is the work done? Fx. Fx. What is the kinetic energy difference? Half mv2 squared final kinetic energy minus half mv1 squared initial kinetic energy. Clear? So what is the work done in this scenario? Force 5 newtons. Force 5 newtons. Displacement 5 meters. Displacement 5 meters. Force 5 newtons. Displacement 5 meters equals here final kinetic energy is half. What is the mass? 2 kilograms. 2 kilograms. What is the final velocity? V. Initial velocity is 0, so initial kinetic energy is 0. Initial velocity is 0, so the initial kinetic energy is 0. So you will get this 2 and this 2 will cancel out. You will get V squared equals 5 squared. V means 5 meters per second. V means 5 meters per second. In the next one, you have an object moving with a velocity of 10. Velocity is 10. Mass is 8 kilograms. Reduced to 5 meters by applying a force of F in opposite direction. You apply a force F in opposite direction and the velocity decreases to 5. Velocity decreases to 5. What is the amount of work done by the force? So again, I can get the value like this. Work done is equal to the kinetic energy difference, right? Work done is equal to the kinetic energy difference. So, kinetic energy difference is final kinetic energy minus initial kinetic energy. Work done is equal to the kinetic energy difference. Kinetic energy difference means final kinetic energy minus initial kinetic energy, which means half. Mass is 8 kilograms. Final velocity 5 squared minus half. Again, the mass is 8 kilograms. Starting velocity is 10. Starting velocity is 10. Then what you get here? This is 4. This is 4. You take 4 out. Then you have 5 squared minus 10 squared. You can do the calculation, right? 100 and here 25, 75, 75 into 4, 300, right? But it is minus 300 of joules. See, 5 minus 10, it's a negative answer. It is a negative answer. Why? Definitely velocity decreases, so you are doing a negative work, not a positive work, right? So it should be minus 300 joules. Clear? You are, in this case, doing a negative work. Clear? So the work done is minus 300 joules. I'll give the interval at 10:30. It's 15 minutes more. And 4 more minutes. Okay. Everything mentions about the interval only. Nothing useful. Again, break. Okay. Pay attention. Pay attention. Potential energy we already know, okay? I mean, pay attention. Kinetic energy means ability to do work, okay? So kinetic energy means due to your velocity, pay attention, due to your velocity, you have the ability to do something, right? That is kinetic energy. Clear? If it go and collide with a certain object, it has the ability to do something, right? Ah, that is kinetic energy. And again, potential energy is also ability to do something, okay? Potential energy is also ability to do something. Actually, potential energy means the energy obtained by something due to its position or due to its shape. Clear? Potential energy means the energy of something due to its position or due to its shape. That means now there's an object here, mass m, mass m. What is its weight? Its weight is mg. Its weight is mg. Clear? Its weight is mg. Now to lift this up, I have to provide a force upward, right? I have to provide a force upward. And at least it should be equal to mg, right? It should be equal to mg at least. And under this force, if I move this to a height of h, under this force, if I move this to a height of h, what is the work done by me? What is the work done by me? Fx. Fx. What is the force? Minimum required force? mg. What is the displacement? H. Displacement is h. Clear? That means you get mgh. You get mgh. Clear? So to lift this up or to change the position of this object, I have to do a certain work, and that work is converted to the potential energy of this object. That work done by me is converted to the potential energy of the object. Clear? That is potential energy. So now due to its new position, it has the ability to do a work, right? If you release this, it will fall down and do a work, right? In that case, its potential energy again converts into its potential energy again converts into its own kinetic energy or work, right? Okay. So this is the definition of potential energy, mgh. So the work you do to change the position of an object converts into potential energy, right? Converts into potential energy. Clear? Again, in our syllabus, when we are defining potential energy, we don't have a predefined potential energy zero level. All we know is the potential energy difference between these two is mgh. That's all. So as a result, when we are doing a question, we should define the potential energy zero level. So if I define this as the potential energy zero level, okay, if I define this as the potential energy zero level, if I place an object m here, its energy would be, if the height is h, its energy would be m g h. Clear? If I move this down, a distance of h, the potential energy would be minus mgh, because it's below the potential energy zero level. Clear? But someone, if they like, they can call this the potential energy zero level. If someone like, they can call this the potential energy zero level. And the basic thing is, when you are doing an essay question, don't start the question without defining the potential energy zero level. Okay, then we don't know what is your potential energy zero level, so we can't give any marks for the potential energies written in the question. Okay, so if someone like, they can define this as the potential energy zero level. They can define this as the potential energy zero level. Then this will be potential energy zero. Then this point will be mgh. Why? The height from here is mgh. Then this will be, height is 2h. So mg 2h. So you can define your own potential energy zero level and write the potential values. Clear? You can define your own potential energy zero level and write the potential energy value. So don't do a essay question without defining what is the potential energy zero level. Okay, clear? Otherwise you won't get any marks. Then next one, elastic potential energy. Elastic potential energy. What is elastic potential energy? Again, there's a spring lie here peacefully. Okay, what I do is I compress it. Pay attention. I compress it. That means I change its shape. I change its shape. Now, due to this change of shape, it has the ability to do work. Due to this change of shape, it now has an ability to do some work. Clear? That work is elastic potential energy, the energy stored due to the change of shape. So here also, I'm providing a force of F and I'm moving it a distance of x. So I'm doing a certain work. That work converts into elastic potential energy. Clear? That work converts into elastic potential energy. Okay. So ideally what happens is, like, do you know this equation F equals kx? F equals kx? No, really? Had this in all of us? No? Oh, okay. This is the equation for a spring. This is the equation for a spring. That means this is the compression of the spring. This is the compression of the spring. And the force appears in a spring is proportional to its compression. Okay? And the proportionality constant is K. Proportionality constant is K. We call this spring constant. We call this the spring constant. Clear? That means if there's a spring, if its spring constant is 1000, okay, if you compress it by 0.5 meters, when you compress a spring, you feel a force on your hand, right? When you compress a spring, you feel a force on your hand, right? Why? Spring creates a force against this compression. Spring creates a force against this compression. and that is given by F equals Kx. That is given by F equals Kx. Clear? So what is the spring constant? K is 1000. Displacement is zero point 0.5. So you get 500 newtons. Now the spring is creating a force of 500 newtons. Clear? Same spring constant can be used when you stretch a spring too. This is the natural length. You stretch it. When you stretch a spring, you feel a force on your hand again, right? Why? It tries to return to its original length, so it pulls you in this direction. That force also you can get using F equals Kx. F equals Kx. So K is 1000. K is again 1000. Displacement is 0.5. Clear? Again 500 newtons. Clear? So if I draw the graph F equals Kx for a spring, this is F, this is X. This is F equals Kx, right? F equals Kx is an Y equals Mx graph, right? Clear? Now, if I'm giving the minimum required force and I'm compressing this by a distance of x, this is the force that I should provide, right? When the compression is 0, force provided by the spring is 0. So almost 0 force is enough to compress the spring. Okay? But when I keep compressing the spring, the reaction force provided by the spring will keep increasing. Clear? So I have to increase the force provided by me accordingly, right? When I compress the spring with the compression, the reaction force provided by the spring will keep increasing. Clear? So I have to change the force according to this. Clear? So if I compress the spring by a distance of x, this will be my force displacement curve, right? With displacement, the force that I should provide should change according to F equals Kx. Clear? The force provided by me should change according to F equals Kx. Clear? So what is the work done in an Fx curve? In an force displacement curve, work done is the area of the curve, right? Work done is the area of the curve. Clear? Which is equal to, this is the force at the moment, I'll call that F1. This is the displacement at the moment, I'll call that X1. This is a triangle, so half F1 X1. This is the equation for the elastic potential energy. This is the equation for the elastic potential energy. Half F1 X1. Clear? This is the equation for the elastic potential energy. But again, I can use F equals Kx, okay? Again, I can use F equals Kx. So I can write here F1 equals Kx1, right? F1 equals Kx1. Clear? So I can replace this F1 by half. Instead of F1, if I like, I can write Kx1. Instead of F1, I can write Kx1 into x1. Kx1 into x1, which will give me half k x1 squared, half k x1 squared. This is another equation to find the elastic potential energy. Okay, so if they tell that the spring constant is 10 and you are shrinking the spring or stretch the spring by 5 centimeters, what is the energy stored? What is the elastic potential energy stored? Half k means 10, x means 5 centimeters squared. Clear? Half k 5 centimeter squared. Clear? That's how you get the energy stored. Clear? Okay. Shall we go until 11? So now you know linear kinetic energy, rotational kinetic energy. This will be learning in the rotational motion. Gravitational potential energy, and elastic potential energy. Clear? Elastic potential energy. So, shall I teach energy conservation too? Will take 1 minute. I'll take 1 minute and finish energy conservation. Then if you like, you can try exercise 5 too. That's why. So 1 minute, 1 minute. Will take only 1 minute. Pay attention. You're not doing anything useful here, right? Just sitting and listening. How can you be tired? Okay. Uh, so the story is this. In a system, I'll explain this after the interval properly, but you can try the questions using this. Total energy is conserved. That means in a system, this is mechanical energy conservation. Total kinetic energy and total potential energy is a constant. Clear? That means kinetic energy will be converted into potential energy will be converted into kinetic energy. So if you somehow find the decrease of potential energy, you can find the gain of kinetic energy. If you somehow find the decrease of the kinetic energy, you can find the gain of potential energy. Okay, that is the idea. I'll explain this later. Then you can try all the questions of exercise 4. All the questions of exercise 4. Interval until 10:50. Yeah. I'll try to give another interval. That's why. If you pass this time, you won't get the second interval. Okay. I'll make it 52. 20 minutes. 53. So it's up to you whether you are getting a second interval or not. Okay. Be here on time and start doing exercise for all the questions. Check. Check. Finish questions of exercise 4. I have given the time for that. Okay. Finish questions of exercise 4. Angle of projection of that question, arctan 4. No, no, it's not 4. It should be a different one. I think the angle of contact would be 45. I'm talking about that frogs question. Someone have asked a question about that. Exercise 4. Exercise 4. Question 1. Find the potential energy of a 5 kilogram object when it is 3 meters, 5 meters, 6 meters, and 8 meters below the ground level. Ground level is the potential energy 0 level. So this is potential energy 0 level. And 3 meters below this. 3 meters below this. What is the potential energy here? What is the potential energy here? Potential energy is minus mgh. Potential energy is minus mgh. What is the mass? 5 kilograms minus mass 5 kilograms g 10 h 3 meters below the ground level. 3 meters below the ground level. Minus 150 joules. Minus 150 joules. This side has been invaded, right? And you did nothing about that, right? Okay. Question 2, part 1. Question 2, part 1. Find the force developed and the potential energy contained in a spring where the spring constant is 10 newtons per meter and when the spring is 6 centimeters stretched. Same thing, just use the fundamental equation. What is the elastic potential energy? Half kx squared, that's all. Half kx squared. Half, what is k? What is k? Spring constant 10. Spring constant 10. Displacement is 6 centimeters. Displacement is 6 centimeters squared. 6 centimeters squared. I mean, it's not like when you shrink it, it's positive. When you expand, it's negative. It's not like that, okay? It's just potential energy. Just positive potential energy, okay? Okay, there's no potential energy 0 level for elastic potential energy, okay? There's no potential energy 0 level or potential energy 0 something for elastic potential energy. If you compress it, still it is positive half kx squared. If you expand it, it's still positive half kx squared, okay? Whether you shrink it or expand it, you get half kx squared, clear? Okay. But for potential energy, gravitational potential energy, you have positive potential energies and negative potential energies. You have positive potential energies and negative potential energies for gravitational potential energy. Question 3. Amount of work done to move 5 kilograms on the ground 5 meters high. Work done is equal to the potential energy difference, right? Work done is equal to the potential energy difference. So what is the mass? What is the mass? 5 kilograms. G means 10. Height is 5 meters. Height is 5 meters. 250 joules. 250 joules. What is the amount of work done by a man lifting object from A, placing it from B? This is a different one. Up to this point, it's using the general equation. mgh half kx squared mgh. Okay. But this one. Question 4. There's a 10 kilogram object here. You place it here. 5 meters down. Sorry, 2 meters down. You place it here 2 meters down. You place it here 2 meters down. Okay. So in this case, work done by me is negative, right? Why? Potential energy decreases. Here in this case, question 4, work done by me should be negative. Work done by me should be negative. Why? Potential energy decreases, right? I got down here. Clear? Clear? So work is a negative work. Potential energy decreases by mgh. What is the mass? 10 kilograms G 10 mg, height 2 meters. So it is minus 200 joules. Clear? Because when you bring this down, potential energy decreases. Clear? And I can explain why it is a negative work in another way. Why? Now see, when I move this down, I have to provide an upward force, right? Why? Otherwise it will just fall down, right? Otherwise it will just fall down. If I leave this, it can peacefully fall down, right? If I leave this, it can peacefully fall down. What I'm doing is I'm restricting its motion. Now I'm giving a force upward on this pencil, right? Now in this case, I'm giving a force upward on this pencil, right? But with that upward force, I'm bringing that down. Clear? Clear? So the force is upward, displacement is downwards. Force and displacement is opposite, which means a negative work. Clear? Which means a negative work. Okay? Force and displacement is opposite, which means a negative work. Clear? Clear? Okay? It is a negative work. That's why you are getting a negative answer. A spring where spring constant is 500 is pulled a total length of 10. A man pulls it to a total of length 12. What is the amount of work done that man has to do here? Do 5 and 6. Get answers for 5 and 6. So in December month you have schools, in January yes, then again on February you should get holidays for all of us, right? Cool. I mean, if we have like few other holidays like this, it'll be done with the syllabus within like 3-4 months. And for all three subjects, stay on that plan of finishing the syllabus before 6 months, before 6 months before the exam. Okay, stay on that plan. Okay, whatever the content you learn very close to A levels is useless. Okay, why? You learn projectiles, motion equations, and all. Then after like 1 or 2 months from that, now only you are comfortable with those equations, right? You learned projectiles, motion equations, all. Then when you just learn them, you were not comfortable with that. Now after doing model papers, term test papers, different exercise, now only you are bit comfortable with projectiles, motion equations. Now it's not something very new, right? So same goes with every lesson. So anything you learn in the last 2 months will be useless for the A level, okay? Any lesson you learn in the last 2-3 months will be extremely useless for A levels, because to season something, to understand something properly, you need at least you need at least you need a 3 months of a gap. Okay, so if you are not finishing syllabus like at least 4-5 months before the exam, at least 5 maybe, then like the whatever the content you learn after that would be useless. Okay, so just check with your seniors. Okay, check with your seniors, all three subjects. Check with your seniors whether the classes you are going, all three subjects, did they finish the syllabus actually on time. Okay, just check that with your seniors. Okay, I mean, you have more than enough people went to the same class. You definitely went to the class through a recommendation, right? You usually go to a class through a recommendation. So ask the from the same people, ask whether like whether they finish the syllabus on time. Okay. For an example, if you got the recommendation from a 26 batch student, now it's like 5-6 months after that recommendation, ask the same person whether you still recommend the guy. Okay, including me. Okay, sometimes things change a lot. Okay, okay, things change a lot. Especially 25 batch. Now they are writing A levels. They know what happened in the last few months. So if you got the recommendation from a 25 batch person, ask the person whether you still recommend the teacher they recommend that then. Okay, things changes a lot. And check whether they finish the syllabus on time, whether the content is okay. Okay, check everything for all three subjects. Okay, for all three subjects you should do that. Okay, I mean, it's not about how we treat you now, it's about how we treat you when it is really close to A levels matters, right? Okay, so that's what matters. So what you should do is Ask from the seniors always for all 3 classes whether they did what they promised. Ask from the 26 batch whether the teacher, you are going for all 3 subjects, are they on the proper plan to finish the syllabus on time or are they not? Check everything, okay? Check everything always. It's really important. The nice things you see now doesn't matter, okay? Because you are a fresh batch, so everyone treats well to a fresh batch, okay? Everyone treats very well to a fresh batch, okay? When a batch gets older, that's when you see the reality, okay? So for all 3 subjects, do that. Check that, okay? So question 5. Question 5. The object, a spring where spring constant is 500 Newton per meter is pulled to a total length of 10 centimeters. A man pulls it to a total length of 12. What is the amount of work done that man has to do here? So here, you can't just write half kx squared then. You can't just write half. What is k? K is 500, right? 500, and what is the difference in length? What is the difference in length? 10 to 12 means 2 centimeters, right? You can't just write it like this, okay? You can't just write it like this, half kx squared. You can't just write it like this, okay? Half kx squared, okay? Why? This is not half k delta x squared, okay? This is not half k delta x squared. This is half k x squared. That means you can't use this for any difference. X doesn't mean the difference. X doesn't mean the difference. It is the gap between the original length and the current length. So if you go from 10 to 12, difference is 2. Okay? From 10 centimeters to 12 centimeters on question 5, the difference is 2. Okay? The gap is 2. But you can't just put the gap here. X means the difference related to the original length. So the original length is 6 centimeters, and it is already stretched to 10 centimeters. Now you stretch until 12 centimeters, right? 12 centimeters, clear? So energy now, potential energy now is, I'll call that potential energy 1. Potential energy 1 is half k. Now the difference is 10. Difference is 10 from the original length. And after stretching it 2 more centimeters, potential energy 2 is half k. Now the gap is 12, right? Altogether, gap is, total length is 10, sorry. Total length is 10, right? So this is 4 then. Total length is 4. And after that, total length is 12, right? After that, total length is 12, sorry. So now, original length 6. Now the total length is 10. So we have stretched by 4 centimeters. After that, half k. Now we have stretched by 6 centimeters. This is the difference in potential energy. That's the work I should do. Okay? From here to here, work I should do is the difference between these two potential energies. Potential energy 2 minus potential energy 1. Clear? Work done is potential energy difference. Work done is potential energy difference. Clear? which means what is potential energy 2? What is potential energy 2? This half k 6 into 10 to the power minus 2 squared minus half k potential energy initial 4 into 10 to the power minus 2 squared. Clear? And when you are doing essay papers, try to go a maximum distance with symbols, okay? That means, since I need to explain this to you guys, that's why I'm writing 4 and 6. If I was doing the paper, what I would usually do is potential energy 1 half k x1 squared, potential energy new half k x2 squared, then the work done is half k x2 squared minus half k x1 squared, then I bring half k out, then x2 squared minus x1 squared. Now only I'll apply values, okay? I usually apply values in the, I won't do that when I'm explaining, okay? Because when I'm explaining, I need to write numbers to make it easy to understand. But if I was writing a paper, I go a maximum distance with symbols, and only in the last step, if there are no symbols, I put symbols as x1 and x2. And only on the last steps, I put values and get the answer. Why? Writing these kind of numbers again and again and again, it's a huge waste of time, right? If I was writing K2, throughout the process, I write this, next step, next step. Okay, writing numbers is a huge waste of time. See, here also, see, writing this consumes a lot of time, right? So if the question goes for like 10 steps, if I put the values here, I have to write these values for 10 more steps, which is a huge waste of time. Use symbols. I'm not talking about simple questions like this, okay? I'm talking about essay papers. In essay paper, you won't get the answer by 2 steps, okay? Sometimes you will have to go for 10 steps. Then if you bring values at the beginning, you will be writing these numbers for 10 steps, okay? Which is a huge waste of time. And the next thing is, other thing is, when the more you write numbers, there's more tendency to make mistakes, okay? Because symbols you can't make mistakes, right? Okay, symbols you can't make mistakes. If you write numbers, there's a probability of you missing something, 10 to the power minus 2 something. You are missing, you may miss values somewhere, right? So more numbers you write, there's more tendency to lose marks, okay, by careless mistakes. Okay, so go until the last step with symbols. Only on the last steps, carefully check the question, carefully write the values. Then you have to be careful only on this step, right? You take your time and carefully check, okay, this is 10 centimeters. That means 10 into 10 to the power minus 2. You carefully write that. Like that, only on this step now you can be extra careful and bring values properly, okay? Otherwise, at every step when you are writing numbers, you have to be careful, which is a huge waste of time, okay? These kind of small habits, when as a compound effect, saves you like 1 hour from the essay paper, okay? At the end of the day, when you build these habits, when you're writing the essay paper, it saves like 1 hour from the paper, okay? 3-hour paper, you can write in 2 hours, okay? You can ask from the seniors, okay? They usually write the paper within 2 hours, 2.5 hours, okay? They don't take 3 hours to finish a A-level paper. Okay. It's not because they are smart, it's because they have some nice habits, okay? Okay. So you can solve this, right? Write K. What is K? K is 500, right? K is 500. So half 500, 6 into 10 to the power minus 2 squared minus half 500, 4 into 10 to the power minus 2 squared. Next question is similar. I'll go to conservation of energy. You solve this and you get the answer, okay? You solve this to get the answer. Energy difference. You goes from 4 to 6 of stretched length. Clear? There was a request to decrease the AC, I think. I didn't see that. Please decrease the front air conditioner. Decrease in the sense? Decreasing temperature. Oh, it's cold? Really? No, right? So I'm actually decreasing, okay? And let me know, I mean, when you tell something, mention it properly. Usually decreasing a AC in the sense decreasing the temperature. To just decrease the number. I mean, the problem is it's a VRV system. You have seasons here and there, right? Here, like summer, winter, summer, winter, summer, winter. Like if you're under the air conditioner, if you're directly with a fan, winter. So there are seasons in the whole. I mean, you have the ability to choose a season, okay? When you're sitting, choose the proper season and sit. Yep. Okay, it's too cold there. See? I mean, can't help. What you should do is when you're sitting, you should choose the proper season in the hall and you should sit. Okay? I mentioned that, right? Actually, one of my friends doing the AC. Like, I mean, he's one of my friends from grade one. Now his company is doing AC all around the Sri Lanka. Means like all the Hamidia, Cool Planet, all the major companies, everything they are doing AC. So he did the AC here too. I asked him a better setup of AC. So this can actually like under best condition, this can cool up to like thrice the size of this hole. It can bring thrice the size of this hole to 19 within few seconds if we maximize the performance. I mean, I just needed a better AC, that's why. He installed, I think, this for like maybe 30 something lakhs. This actually cost around 80 lakhs or something like that. This is a good setup. But the problem is it has seasons. So I can't help with that. When you are sitting, you just choose the proper season and sit. Okay. Okay. Let's move forward. Pay attention. Anyone still writing this question? This one? Okay. I mean, I'll explain this a bit again. Only this one, right? Pay attention. Pay attention now. Uh, I mean, its original length is 6. Initially, I stretched it by 4 centimeters, right? Okay. That's why the length becomes 10. Then I stretch it up to 12. That means 2 additional centimeters. 2 additional centimeters. Clear? This is 4 and we stretch it 2 more centimeters. Clear? So, potential energy equals half kx squared. In this equation, x doesn't mean the difference. So when you go from 4 to 6 of stretched length, you can't put 2 here. Here x means the difference from the original length. So initially, it was stretched by 4, right? So initially energy was half K. Initially energy was, stored energy was half K 4 squared. Clear? Now what is the overall stretched length? 6. So now the potential energy is half K 6 squared. Clear? And the work I do from here to here is the difference of this potential energy. Clear? That is the work I do. Clear? Got the idea? It doesn't work for the difference. It works from the difference from the original length. Equation is defined for the difference from the original length. Clear? Clear? So can you please increase the temperature of AC number 17? There are only 4 ACs. It's 2, 1, 1. Can't help. Then you just, when you're sitting in the class, just choose the proper season and sit. Okay, can't help about this. Okay. And at the end of the day, not getting a very good result, won't harm your life. Okay. That guy didn't get a very good result. Now he's doing very well. I think they are doing a revenue of maybe 100 lakhs per month at least. So it's not bad. Yeah. But he's doing a degree. And his degrees, he's doing AC. And his degrees, uh, environmental conservation and financial management. I think Colombo physical degree. You are doing you are like putting AC everywhere, and your degree is environmental conservation and financial management or something like that. So all I remember is it had the term environmental conservation. The most harmful thing to the environment. Okay. And he's doing his final year project these days. His final year project is they are doing VRVACs. Not normal ACs. VRVACs are better usually. His final year project is proving that VRVACs are better for the environment, which is actually not. Okay. Uh, Pay attention. Now, energy conservation. Conservation of energy. Everyone, be silent. Everyone. Conservation of energy. So, initial conservation of energy is not what we are going to use in our syllabus. Original conservation of energy means whole energy is conserved. That means whole energy means energy can, now when I'm working, what is happening? My chemical energy stored converts into kinetic energy. Clear? When I drop this, potential energy converts to kinetic energy. Clear? These AC machines do a conversion between electrical energy and heat energy. They are doing a conversion, they are performing energy between electrical energy, they use electrical energy to shift the heat energy. So that is conservation of energy. Conservation of all the energy types together are conserved. Okay? That means sound can convert into heat, heat can convert into kinetic, kinetic can convert into potential, potential can convert into chemical. But when you take everything as a whole, it is conserved. It is conserved. That is original conservation of energy. in our syllabus, we can't discuss that at the moment, because in the heat lesson, we are learning about heat energy. In the optics lesson, we are learning about optical energy. In the last lesson, we are learning nuclear energy. Like that, there's a bunch of lessons forward, and under each lesson, we'll be learning about different energies. At the moment, we have learned only kinetic energy and potential energy. Clear? At the moment, we know only kinetic energy and potential energy. Clear? Ah. So, uh, kinetic energy and potential energy together, we call that mechanical energy. Kinetic energy and potential energy together, we call that mechanical energy. And what we have in our syllabus is mechanical energy conservation. What we have in our syllabus is mechanical energy conservation. That means when energies are not converted into other energy types, mechanical energy is conserved. That means potential can convert into kinetic, kinetic can convert into potential, but other than that, when there are no other conversions, when the energy does not convert into other energy types, then the mechanical energy is conserved. So what we have in our syllabus is not energy conservation, mechanical energy conservation. That means we do all the questions assuming that energy will not be converted into other energy types like optical energy, heat energy, chemical energy, anything else. Okay? Clear? That is the idea. Yep. So let's go to exercise 5. Let's go to exercise 5. Let's start with question 1 and 2. You don't have to use energy conservation for 1 and 2. You don't have to use energy conservation for 1 and 2. For 5, 6, 7, you have to use conservation of energy. For 5, 6, 7, you have to use conservation of energy. Let's start with these questions. There's a question about dark matter and dark energy. It's a different realm of physics. We have to start with Einstein physics first. I usually teach Einstein physics, okay? Don't worry. I teach Einstein physics whenever required. In the magnetics lesson, I mean, there's a magnetic lesson in our syllabus, but all we know is Newton physics. And Newton have nothing to do with magnetics, okay? The guy knew nothing about magnetics. So without Einstein physics, you can't understand magnetics properly. That is one of the main reasons for students not understanding that lesson called magnetics. But I usually teach the required Einstein physics part before that. So yep, you'll learn about this stuff. I never like ask you to like think that it's like that. ඒක එහෙමයි කියලා ගන්න කියලා මං කියන්නේ. I usually teach, okay? If you can't understand, it's not my problem. when a mass of 10 kilogram is at rest on a smooth horizontal plane, when a horizontal force is applied on it. Before that, let's do that question. I'll discuss this one because I received the correct answer from many students. The crucial point in this question is finding out the uh, point we are talking about. This shows the distance between a certain point and this object. Okay. So assume that it is this. Assume that the point is this. Then the distance should just increase from this point and again decrease. Okay. Assume that the point I'm discussing is this. Then there's a huge distance. Then it should decrease when it moves up. I mean, think that this is the point I'm discussing. This is showing the distance from distance between this point and this one. Then what happens? Then initially there's a huge distance. When it moves up, distance decreases, right? Initially this is the point, this is moving up. Then the distance decreases, right? Distance between them decreases to a very small value. Then again when this goes down, distance between this and this increases, right? So the graph should go like this. Clear? Okay. So whatever you do, you will get a graph like this or like this. Okay. If we think that the point we are thinking is this, then initially there's a good distance. Now distance decreases and go to 0. Again distance increases. Again distance decreases between them and go to 0. Again increases, right? Clear? If this is the graph between this point and object, what would happen is it has a distance, goes to 0, again distance increases, again goes to 0, again distance increases, right? But this doesn't look like any of them, right? Okay. It does not go to 0 like this. It is not like this or this. Okay. Clear? So this kind of a shape could happen. I mean, with none of the points in this line will give me this graph. So the only possibility is the object moves up here, V. Okay. And the point I'm discussing is this. Somewhere like this. See? Now at the beginning you have 6 root 5 distance between them. At the beginning you have a distance of 6 root 5. Clear? At the beginning you have a distance of 6 root 5 between them. Just draw this larger. You throw this up. You are here at the beginning. At the beginning this gap is 6 root 5. Clear? Then the distance decreases, and when it is here, you have the smallest distance, 6. You have the smallest distance, 6. Clear? Then it goes up. At the highest point, it is this. You have a distance of 10. 10. Clear? Then again, it returns to this point, which gives you the distance of 6 again. Then again it reach here, which gives you 6 root 5 again. So this is the only possibility. So the whole question is about finding the correct point. After that you can find the answer, okay? Whole question is about finding the correct point. Clear? So now you can find the maximum height. This is the maximum height, right? So just apply Pythagoras and find x. Then apply Pythagoras and find y. Height is x plus y. So this is 10, this is 6. So you can write 6 squared plus y squared. 6 squared plus y squared equals 10 squared. Then here you will get 6 squared plus x squared. 6 squared plus x squared equals, from this triangle, 6 squared plus x squared equals 6 root 5 squared. Do I have the answers for this? This will be, what is the answer? Do I have the calculator? Sorry? 8. Y is 8 and x 12. After solving this, y is 8 and x is 12. That means I know the maximum height of the projectile. Maximum height of the projectile is 8 plus 12, which gives me 20, right? So you throw this up with a velocity of v, and it reach a maximum height of 8 plus 12, 20. And at the highest point, we know that the velocity is 0, right? So you can find the starting velocity by applying v squared equals u squared plus 2as. At the highest point, velocity is 0. Starting velocity v squared plus 2. This is an upward equation. Gravity is downward and gravity is 10. So minus 10, minus 10, minus 10, and the height is 20. Height is 20. So you get 0 equals v squared minus 20 squared. That means v squared equals 20 squared. Then v equals 20 meters per second. Try the other question too. Do we have answers for the other one? The question of the frog? Try that one too. I mean, few minutes after break, they're asking, are we getting another break? Best thing you could do for the world is don't be doctors. Engineers are fine. You're not going to do any harm. Don't be doctors, okay? I mean, I know you people, and somehow you people are going to be future doctors, right? That's why I got a new insurance actually, which covers like, I mean, now my insurance cover everything. That means I can go to any country, whatever the country I like, can get medicine. They cover any country. I actually upgraded my. I initially it wasn't there with any country. Now it allows to get medicine from any country. Because can't afford to get medicine from you guys. Okay. Still writing this? Someone? Someone? No, right? Okay. Let's continue to the exercise. Okay. When a mass of 10 kilograms, when a mass of 10 kilograms is at rest on a smooth horizontal plane, when a horizontal force is applied on it, it moves a distance of 100 meters. You apply a horizontal force and it moves a distance of 100 meters. It moves a distance of 100 meters and attains a velocity of 20. I think you are starting at 0 velocity and attains a velocity of 20. Attains a velocity of 20. Find the force exerted on the object. Quite simple. Whatever the work you do, Fx, converts into kinetic energy difference. Whatever the work you do on the object converts into kinetic energy difference, right? So what is the work done? You apply a force of F and the displacement is 100. Displacement is 100. Force F, displacement is 100. Displacement is 100 equals final kinetic energy half 10 kilograms. Final velocity is 20. 20. Final velocity is 20. Initial velocity is 0. So initial kinetic energy is 0. You solve this and you get F force. So you get F equals 10 into 400 over, here you have 2 and another 100. 10 into 400, 2 and 100. 20 newtons. 20 newtons. Question 2. A bullet of mass 20 gram is struck horizontally with a velocity of 200 on an stationary plate of thickness 5 centimeter kept vertical so that the bullet moves through the plate. If the resisting force exerted by the plate on the bullet is 6,000 newtons, what is the velocity with which the bullet exits the plane? So there's a plane like this. A bullet goes through that. a bullet goes through that. The bullet enters with a velocity of 200. Bullet enters with a velocity of 200 and the mass is 20 grams. Mass is 20 grams. Then on the way, they will feel a resistive force, the bullet will feel a resistive force F, and the value of F is 6,000 newtons. And under this resistive force, the bullet will move a distance of, the thickness of the plate is 5 centimeters. Thickness of the plate is 5 centimeters. 5 centimeters. Then it will go like this and come out here with a certain velocity. Now again, the opposite work done by this 6,000 newtons throughout this length will reduce your kinetic energy, right? Clear? That means the opposite force is Fx will reduce your kinetic energy. Will reduce your kinetic energy. Clear? So what is the opposite force? Or else I'll write it properly, I mean with all the fundamentals properly. That means half mv2 squared minus half mv1 squared. This is kinetic energy difference. Final kinetic energy V2, initial kinetic energy V1. Clear? Now if I write this properly, this is a negative work, right? This is a negative work. So the force is 6,000. Force is 6,000 and displacement is 5 centimeters. 5 centimeters. Clear? And you put a minus mark here because it is a negative work. Clear? And when you are writing values also in an essay paper, even this 20 grams, I should have written as 20 into 10 to the minus 3 kilograms. This also I write after the conversion. Why? In an essay paper, when you have a huge diagram, if some are in grams, some are in centimeters, some are in millimeters, whenever you put values here, you have to do the conversion yourself. Each time you have to waste your processing power. But if you put everything in the proper SI unit, after the conversion you put everything in the diagram, then you just have to write it here. You just have to write it here. Clear? Okay. It saves some processing power and time. Okay. So this is the work done. Equals half mv2 squared. Kinetic energy difference means final kinetic energy minus initial kinetic energy. What is the mass? Mass of the object 20 grams. See, now I have to do the conversion again and again, which can increase my careless mistakes too. 20 convert into kilograms. V2 squared. V2 squared minus initial kinetic energy half here 20 grams, 20 converted into kilograms, velocity V1 200, so it is 200 squared. 200 squared. You solve this and you get V2. Clear? You solve this and get V2. Next, let's go to question 5. Just finish the whole exercise 10, 11, 12, 13, 14, 15. Try to finish the whole exercise. Okay. Question 5. Question 5. The object is tied to a string and the string is pulled and is lifted 4 meters above the lowest point of the path and dropped. It will go in a path like this. Lifted 4 meters initially. Lifted 4 meters initially. Can the mechanical energy conservation be applied to the motion of the object? What is the velocity of the lowest point of the path? What is the velocity of the object when it is 1 meters above the lowest point? So here in this question, there's a very important theory question here. Pay attention. So if there's something like this, moving at a velocity of 10, and if I apply a force of 100 on this, can I apply conservation of energy to this guy? Can I apply conservation of mechanical energy to this guy? No. Why? There's a third there's a third force involved. This 100 newtons, right? This 100 Newton is an external thing. This may be a person pushing this, which means a conversion from chemical energy of the person to mechanical energy. Or it may be an engine pushing this, which means a conversion of fuel chemical energy into mechanical energy. So when there is an external force, mechanical energy conservation is not valid. Clear? You can apply mechanical energy conservation only when there is gravitational force. When there's gravitational force, it's okay to apply mechanical energy conservation. Why? Gravitational force is the force that creates potential energy. Clear? When you have the gravitational force mg, it's okay to apply energy conservation, mechanical energy conservation. Why? Gravitational energy is the force that creates potential energy, which is a type of mechanical energy. But if there is any other force other than gravitational force, okay, or the force by a spring, still okay. If there's a force by a spring, still okay. Why? Force of a spring is the force that creates elastic potential energy. So if you have any forces other than this, gravitational force or force of a spring, okay, which is behind gravitational potential energy and elastic potential energy, other than this, if you have any other force, you can't apply mechanical energy conservation. Clear? Because there's something involved in the process. Clear? There's something involved in the process. Clear? But in this case, also you have several other forces. What are the forces? You have the weight involved. So the first question is, can you apply mechanical energy conservation, right? First question is, can you apply mechanical energy conservation? You have the weight downward and a tension in this direction. Weight is not a problem because it is the force behind gravitational potential energy, so it is okay. But what about the tension? What about the tension? Tension is an third party, right? It's an external force. Clear? Tension is an external force. Clear? So when there is tension, can I apply mechanical energy conservation? Ideally, no. There's a third force involved. Clear? There's a third force involved. Clear? But the thing is, here, I can still apply mechanical energy conservation. Why? What is the reason? Yes, there is a third force. But at this point, tension is in this direction. The object is moving in this direction, right? At this point, tension is in this direction. Object is moving like this. Clear? At this point, tension is in this direction and object is moving like this. See, throughout the process, tension and the direction of motion is perpendicular. See, throughout the process, tension and the direction of displacement is perpendicular. So why can't we apply mechanical energy conservation when there is a third force involved? Because that third force will do a work and that work will change the energy. Third party will do a work and it will change the energy. But in this case, this third force, tension, is always perpendicular to the motion. That means perpendicular to the direction of motion always. So a perpendicular force can't do a work, right? A perpendicular force can't do a work, right, on an object? Why? Cos 90 is 0. If you have a perpendicular force like this, and if the object is going like this, there's no work, right? Why? Work equals displacement x, and the force component in this direction would be, if this is f cos 90, right? F cos 90, which is 0. Cos 90 is 0. Okay? So a perpendicular force can't do a work on a system. Clear? So it can't affect the energy of the system. So in this case, although you have the tension, it does not affect the energy of the system because it can't do a work because it is perpendicular. Clear? Clear? So mechanical energy conservation is still valid. Mechanical energy conservation is still valid. Clear? Write that in your own words, okay? Question 5, first one. Mechanical energy conservation is valid or not? Yes, it is valid. Yes, it is valid. Tension is perpendicular to the motion, so the tension can't do a work on the system, so the mechanical energy is conserved. Okay, answer can be simple like that. Tension is always perpendicular to the direction of the motion, so the tension can't do a work on the system. Tension can't do a work on the system, so mechanical energy is conserved. Question 5 part 2. Question 5 part 2. What is the velocity at the lowest point of the path? What is the velocity at the lowest point of the path? Now it is easy. Okay. Now it is easy. Why? What is the height difference? 4, right? Height difference is 4. So the first step, let's define the potential energy zero level. I'll define this as the potential energy zero level. This as the potential energy zero level. And I'll call this point A, this point B. According to conservation of energy, kinetic energy plus potential energy at A is equal to the kinetic energy plus potential energy at B. Kinetic energy plus potential energy at A is equal to the kinetic energy plus potential energy at B. Clear? So at A, kinetic energy is 0. Let's take the mass as m. Here the kinetic energy is 0. Why? At the highest point, object is stationary, right? Object is stationary. What is the potential energy here? M G H. In this equation, H means always the height. H means always the height, right? So what is the height from the potential energy zero level? 4. mg4. Here, what is the kinetic energy? Let's assume that the velocity is v. If the velocity is v, here the kinetic energy is half mv squared. Kinetic energy is half mv squared. What is the potential energy? Potential energy 0. Why? You are at the potential energy 0 level here. You are at the potential energy 0 level here. Clear? So you solve this. You solve this. You divide the equation by m cancels out. You take 2 here. So you get v squared equals m and m cancels out. You take 2 here. So you get 2 into g into 4 equals v squared. So you will get here, g means 10. So 4 into 2, 8. G is 10, which means 80. So the velocity will be square root 80. Velocity will be square root 80. Square root 80 meters per second. Square root 80 meters per second. Clear? 80 meters per second. You don't need another interval, right? I'll try to finish early. Go to question 6. I mean, if you can't sit for like 10 hours, I mean, you'll suffer on a day like this after 2 years. Some A-level students may come here now, I think. Have to ask about the paper. Oh, I think the paper is 8:30. Yes, right? Yeah, it's over at 11:30, right? Where's my other phone? I think the PO paper, I mean, I don't know anything about bio. Do they have the bio paper today? Yes, right? I don't know nothing about that, but usually PO paper, PO maths paper is usually easy. And we expect the paper to be as difficult as possible. Otherwise, there's no point of giving very easy A-level papers. Then the universities will be filled by dumb people. So then after that, lecturers suffer. Then after that, the industry suffer. Then they don't give projects to our country. Then they go for European countries. It's a huge. I mean, if the A-level paper is easy, if the A-level paper is really easy, I mean, it's like a. I mean, the economic impact comes usually after 15 years. If today's A-level paper is easy, if this year's A-level paper is actually easy, the economic impact from that will come after like 15 years. You bring dumb engineers in, they underperform, they go to the industry, again underperform, they ruin some international projects, then the international, like we go down in international standards, we lose many international projects. Then they go for other countries. That happened to India. That's why we are surviving as a country in IT industry. It happened to India. They produced like millions of engineers. So their standards went down. As a result, we start getting projects. That's why our IT industry is surviving. But if we give very easy papers for A levels, the process continues and the economic impact will come after 15 to 20 years. We don't even think that it was because of the A-level paper, but the main reason is there. That's a fundamental exam we choose for national universities. Okay, what is the velocity of the object when it is 1 meter above the lowest point? So this is the system. Initially 4 meters, now 1 meter. I'll choose this as the potential energy zero level. I'll choose this as the potential energy zero level. A and C, kinetic energy plus potential energy at A equals kinetic energy plus potential energy at C. Here the kinetic energy is 0. Here the kinetic energy is 0. And the potential energy is mg, height from the potential energy 0 level 4. Here the velocity may be v2. So the kinetic energy would be half m v2 squared plus mg. Now the height is 1 meters. Now the height is 1 meters. Clear? Okay. You divide by m. You divide by m. Then you get v2 squared equals 4g minus g into 2. V2 equals square root. This is 3g, which means 3 into 10 into 2, which is square root 60 meters per second. Square root 60 meters per second. Interval. How early are you going to finish? No idea. Interval. I mean, interval is for people who are tired. You didn't do anything useful. Same. I mean, when you're learning subjects like maths and physics, try to learn them as logically as possible, okay? Don't study, try to understand things. Because at engineering faculty, we see how people suffer, okay? I mean, the whole objective of A level is not getting 3 years and getting into the faculty. It's about improving your intelligence level, okay? If you don't do that properly, you're going to suffer at the university. Yeah, we see that every year in the engineering faculty. So, I mean, yeah. So like, try to like learn everything logically, especially maths and physics. Try to understand everything. Ask questions. Okay. Question next 6. Question 6. Question 6. So shall I finish at 1:30 then? You need an interval now and finish at 2. Really? I'll think about that at 12:45. Question 6. Question 6. When two springs of spring constant 100, okay, pay attention. This is 30 kilograms. Um, Here spring constant is 100. Here spring constant is 200. So you leave it here and let it go down and it go here and stops here. What happens in this process actually? You lose some potential energy. You lose some gravitational potential energy, but it is stored as elastic potential energy. Clear? If it go down by a distance of x, if it go down by a distance of x, this spring will extend by x and this spring will extend by x. You go down means you lose some potential energy, gravitational potential energy. You lose some gravitational potential energy, but you gain elastic potential energy. Clear? You lose gravitational potential energy, but you gain elastic potential energy, right? So you always don't have to write energy conservation and this and that is equal. You can just say, okay, potential energy lost is equal to the kinetic energy, equal to the elastic potential energy gained. That means you go down by mgx. That is the potential energy lost, right? You go down by x. So the gravitational potential energy lost, mgx. When you go down, you lose potential energy, right? By mgx. And what is the elastic potential energy gained in that process? For this spring, half k1x squared. For this spring, half k2x squared, right? For the spring, it's half k1x squared. For the spring, it is half k2x squared. Clear? I mean, you can divide the whole equation by x. Then you have mg equals x over 2 k1 plus k2 x over 2 k1 plus k2. Then you write x equals 2 mg over k1 plus k2. Clear? You write 2 mg over k1 plus k2. Clear? 2 mg over k1 plus k2. Clear? Then you get, what is x? 2. What is the mass? 30 kilograms. G means 10. G means 10. What is k1 plus k2? 100 and 200, right? K1 plus k2 is 100 plus k1 is 100, k2 is 200. Then you get 2 into 300. Here again 300. 300 cancels out. You get 2 meters. Clear? You get 2 meters. Let's go to question 7. Question 7. Actually, we can finish work power energy theory today. Only 2 more theory points left. Collisions, and power and efficiency. 2 very simple concepts. So do you still need the interval? Question 7. Raise your hand if you need the interval. See, there's very few who need the interval. I can finish by 1:30. You need the interval. I can give a maximum of 10 minutes then. I can give a maximum of 10 minutes and finish the lesson today. Otherwise, you will have to come again next week. It's pointless, right? Don't you have anything else to do at home next week? Anyways, I'm gonna finish the lesson today, okay? So maximum I will be able to finish it at 2. I can give a 10 minutes interval, but I'll go until 2. Yeah, it's anyways gonna finish at 2. Yeah. I mean, I was planning to end at 1:30 if you are not getting the interval. Okay. I'll do a small theory part and give you the interval, 5 minutes. But it is a 10-minute interval so that I can give you questions to do in the interval. That's why. Uh, Pay attention. Uh, what is the point of getting so many intervals? Okay. And you stay at school right from 7:30 to. Now you have to stay until 2, right? Okay. Lucky I finished school. Okay. Um, Pay attention. Let's do the other questions after the interval. I'll finish one more main theory part. Then we are almost over with theory. It is collisions. It is collisions. Then I'll finish collisions. Then return to the exercise 5 again. Okay. Then return to exercise 5 again. Pay attention. Uh, Collisions means objects can collide with each other. Objects can collide on a wall. There are like different collisions can happen, right? There are two main types of collisions that we discuss. One is elastic collisions and the other one is inelastic collisions. Elastic collisions means kinetic energy of the system remains constant. Kinetic energy of the system remains constant. That means if you collide with a wall with a velocity of 5, you bounce back with 5. Clear? Your kinetic energy is conserved. If you have two objects, M1, V1, M2, V2, okay, and if they collide, okay, and after the collision, if the velocities are V3 and V4, still the kinetic energy is conserved. That means what is the kinetic energy before the collision? Half M1 V1 squared plus half M2 V2 squared equals, what is the kinetic energy after the collision? Half M1 V3 squared, half M1 V3 squared plus half M2 V4 squared. Clear? Clear? Kinetic energy before the collision is equal to the kinetic energy after the collision. Clear? These are elastic collisions. Again, in this case, there's an object going like this, mass 5, velocity 3. It will bounce back with the same velocity. Clear? It will bounce back with the same velocity. Clear? And inelastic collisions are, in an inelastic collision, you lose some kinetic energy. That is the natural thing, okay? Naturally, collisions are not elastic, inelastic. That means if the velocity was 3, now it becomes 2. If the velocity was 5, now it becomes 2. Like that, you lose some kinetic energy as a result of the collision. Clear? This is inelastic collisions. Clear? So in this case, like now for this you have to know conservation of momentum. That means you have to finish Newton's law. Why? Now for them, for people who have finished Newton's laws, we have finished that in the class. Now you can like solve systems. That means if this is 2 kilograms, if the velocity was 3, if this is 4 kilograms, if the velocity was 2, now they will collide. after the collisions, now if I ask the velocities v1 and v2, okay, what can you do now? Momentum conservation first. Conservation of momentum. What is conservation of momentum? 2 kilograms into 3 plus 4 kilograms into 2, 2 kilograms into 3 plus 4 kilograms into 2 equals 2 kilograms into V1, 4 kilograms into V2. Initially, I mean, this won't affect a lot. I mean, this is a very small area. So if you haven't finished conservation of momentum, don't worry. This is a very small area. Pay attention. Okay. Don't die there, okay? So 2 into 3 plus 4 into 2 equals 2 into V1 plus 4 into V2. But initially, after finishing conservation of momentum, they had to give us V1 or V2 in order to find the other one, right? They had to give us V1 or V2 in order to find the other one. Clear? But in now we have another equation. What is that? If it is an elastic collision, pay attention. If it is an elastic collision, kinetic energy before half mv squared, half 2 3 squared. Here the kinetic energy before half 4 2 squared equals what? Equals after the collision half 2 v1 squared plus half 4 v2 squared. Clear? Clear? Now you have v1, v2, two unknowns and two equations which you can solve, right? Now you can solve. Clear? Clear? Got the idea? Now you can solve using this. Because initially we had only conservation of momentum. Now we have kinetic energy before the collision equals kinetic energy after the collision. So what I need you to do is go to exercise 4. We are almost done with the theory. We have only very few stuff remaining. It will take only 15 minutes. The remaining theory part will take only 15 minutes. So go to exercise 4, question 7. Sorry? Sorry, exercise 5, right? Thank you. Go to exercise 5, question 7, 8, 10, 14 and 15. And exercise 6, question 1, part 1 and part 2. For this, you have to know conservation of momentum. Otherwise, you can't do this. For this, you have to know conservation of momentum. Okay. So this is the idea. Try these questions. If you need an interval, you can get that and be here by maybe 1 p.m. Okay. But keep trying the question if you don't need the interval. Okay. I won't give a lot of time to try these questions after the interval. So get a 10-minute interval. And like there may be a lot of traffic outside, I think, because now the 26 batch students are coming to write the A-level paper. I mean, after the A-level, they write the A-level paper. I mean, 25 batch went for A-levels. Now 26 batch is writing the same paper today here. Around 1 p.m., I think they are starting. Yep. So be here within 10 minutes. Try these questions. If you actually need an interval, take that. Otherwise, keep doing the questions, okay? I'll quickly start the discussion. Question? Okay. Question 7. Exercise 5, question 7. Exercise 5, question 7. There's a plate, 10 kilogram, plate, 10 kilogram, on 4 springs. On 4 springs, spring constant 1000. Spring constant of 1 is 1000. Child of mass 40 kilograms. Child of mass 40 kilograms jumps from above onto the plate from rest. Then the plate has moved down 0.5 meters when it comes to instantaneous rest. When the system is at rest, again, with the person, the plate moves a distance of 0.5 meters. Plate moves a distance of 0.5 meters. Plate moves a distance of 0.5 meters. From what height edge did the boy jump? This is the height. From what height did the boy jump? H. What is the upward acceleration of the body after the instant rest? Again, conservation of energy. There is no like there is no kinetic energy in this system, and there is no kinetic energy in this system too, right? Why? Now everything is stationary. After that, when this lands on this and it goes down, now again everything is stationary, right? Here everything is stationary. Clear? And again here everything comes to rest. At the end, everything comes to rest at the lowest point. That means everything is stationary, right? Clear? So no kinetic energy involved in the question. At the middle, when it falls down, there's some kinetic energy. But when you consider the absolute beginning and the absolute end, there is no kinetic energy, right? When you consider the absolute beginning and the absolute end, there is no kinetic energy, right? Clear? So the idea is this. Okay. The idea is this. I'll take this as potential energy 0 level. Okay. I'll take this as potential energy 0 level. This is potential energy 0 level. This is potential energy 0 level. Clear? For the whole question, I'll use that as the potential energy 0 level. in this case, okay, okay. Now, there's a lot of work to do here, right? There's a lot of work to do here. Because ideally, in the initial system, there's a certain elastic potential energy stored, right? If I calculate one by one, pay attention. If I calculate one by one, in the initial system, there are few potential energy components, right? There are few potential energy components. I'll forget the thickness here and I'll think that this returns to the lowest point here. Okay, it falls like this. Now initially, potential energy of this block is mgh. Potential energy means mgh. Gravitational potential energy. Potential energy gravitational. Okay. Initially it is m. M means 40. M means 40. G means 10. What is the height here? What is the height here? Not h. This is my potential energy zero level, right? This is my potential energy zero level. So it is h plus 0.5, right? Initially, this is at a height of h plus 0.5. Clear? H plus 0.5. Clear? Clear? Now what? And what about the other guy? This one. There's another gravitational potential energy component here. 10 kilograms m. G means 10. G means 10. What is the height of this 10 kilogram block? What is the height of this 10 kilogram block? It is 0.5, right? It is 0.5. Clear? It is 0.5. And the next thing, initially, these springs are compressed a bit, right? Due to this weight, initially these springs are compressed a bit, right? What is the compression? That I have to find, okay? That I have to find. So what happens is, this is 10 kilograms. So the weight of this block is 100 newtons. The weight of this block is 100 newtons. Clear? That 100 newtons is held by 4 springs. That means kx into 4. Kx into 4, right? It's held by 1, 2, 3, 4. 4 springs. So initially this weight is held by 4 into kx. So what is x? 100 over 4k. What is k? 1000. 1000. Clear? 100 over 4k. Okay. What is 100 over 4k? It's 25 divided by 1000, 0.025, right? 0.025 meters, right? Clear? Actually, the question is meant to neglect this, okay? Because it is too small compared to that 0.5 we are getting later, but I'll consider and do everything. So initially there's a compression in these springs, and the compression is 0.025, right? Due to the weight of this 10 kilograms. Clear? 100 equals 4kx. Clear? So initially there's a potential energy elastic, which is half kx squared, right? Half kx squared. Clear? So it is half, k means 1000, spring constant 1000, and initially they are shrinked by 0.025, right? Their compression is 0.025. Clear? Initially they are compressed by 0.025 squared, and there are 4 springs like this, right? Half kx squared, and there are 4 springs like this. Clear? These are the all energy types before. What are the energy types after? Potential energy gravitational 0. Why? Potential energy gravitational 0. Why? Everything falls to the potential energy 0 level, right? If I forget the height of the object, and they haven't given us anything about the height of the object, potential energy, everything has returned to potential energy 0 level in this case, right? Clear? That means overall gravitational potential energy is 0. Clear? And initially, springs were shrinked by a distance of 0.025. Clear? That means this is their original length. This is their original length. Due to this weight of 10 kilograms, initially it was shrinked by 0.025 from their original length. Clear? Now they get shrink by additional 0.5. Clear? So now the elastic potential energy is half, k means 1000, k means 1000. Now what is the overall compression? 0.25 plus now the additional 0.5. Clear? Clear? 0.25 plus additional 0.5. Clear? So 0.5 plus 0.025 squared. Clear? And there are 4 springs like this. Clear? Initially the system is stationary. Finally also everything comes to rest. So no kinetic energy throughout the system. So sum of this side is equal to sum of this side. You solve that and get H. Clear? Right up to this point. This is the overall mechanical energy before. This is the overall mechanical energy after. Sum of this side should be equal to the sum of this side. Clear? Got the idea? These are gravitational potential energies. Gravitational potential energy of this guy plus gravitational potential energy of this guy, right? This is potential energy 0 level. So mg h plus 0.5 initial gravitational potential energy of this. Again for these 10 kilograms, mg height is 0.5. Initial kinetic energy, initial elastic potential energy, 4 springs. So weight is 100 equals 4kx. So 100 equals 4 into 1000 into x. And the compression at the moment due to this 100 newtons of weight is 0.025. So half kx squared. X is the compression from the original length, which is 0.025. Clear? compression from the original length 0.025. Clear? Due to this 100 Newton weight that it already has. Clear? And there are 4 springs like that. So the energy should be multiplied by 4. And after everything falls to potential energy 0 level, so no gravitational potential energy. Elastic potential energy, it is half kx squared. X is the compression from the original length. Initially there was a compression of 0.025. Now additional compression of 0.5. Overall compression is 0.5 plus 0.025. This is the overall compression, half k x squared. Clear? This is the overall compression, half k x squared. And again you have to multiply by 4. Why? There are 4 springs. You at this side, these two sides should be equal, because the total mechanical energy is a constant. Clear? Total mechanical energy is a constant. Clear? Go to question 8 next. Still, this is not over. You have to add these two sides. Go to question 8 next. Question 8. Okay. Now, total energy before should be equal to total energy after, which means here 40 into 10 into h plus 0.5 plus 10 into 10 into 0.5 plus elastic potential energy. Here you get 4 over 2 means 2 into 1000 into 0.025 equals, in this side, 4 divided by 2 into 1000 plus 0.5 plus 0.025 squared. sum of this side should be equal to the sum of this side. Then you solve this and find h. Okay, you solve this and get the final answer h. Clear? Next part of the question is unnecessary because it's not related to work power energy. This is enough for that. Let's go to question 8. Let's go to question 8. So shall we do a similar session next Monday? Yes, right? Something similar. I mean, like something similar in the sense, more work power energy questions, maybe some more coplanar questions, some term test paper discussions, a bundle of some stuff. Okay. Yeah, term test haven't started yet, right? By next Monday, no, right? Really? Really? Sorry? Yeah. Yeah. Uh, like, when is next Monday? I mean, otherwise you are just gonna waste time at home, right? That's why. Yeah, let's do next Monday and Tuesday to a similar session. Next Monday, as usual, full English medium one and the Sinhala and English mixed one. As usual, not tomorrow. Tomorrow you have the Sinhala and English one. Same plan next week. I'll inform everything. I'll inform the plan. Most probably more work power energy questions. We'll be starting coplanar forces this Thursday, a new lesson. This Thursday and next Sunday. So some more questions from maybe coplanar forces. And I'll choose a bunch of term test papers to discuss. Okay. I'll inform you the plan. Okay. I'll inform you the plan. So next Monday and Tuesday, the same plan as this week confirmed. Okay. And Thursday classes and Sunday classes will continue as usual. Okay. But today we are finishing work power energy theory anyways. Okay. And this week also, maybe Friday evening, and as usual, I'll be discussing some term test papers too. Okay. Some term test paper discussions would happen as usual. Okay. Those plans will continue. Next Sunday night, mechanics from beginning sessions. This Friday night, term test paper discussions, everything would continue as usual. You can use those sessions to cover up mechanics if you have missed that. To understand term test papers, you can join the term test paper discussions. Everything continue as usual. And next Monday, Tuesday, a similar plan. I'll inform what I'm going to do on those 2 days, but the days are confirmed, okay? Days are confirmed. More like a question session, okay? It will be more like a question session. Yeah. This Thursday we are starting a new lesson, coplanar forces. It's not connected with previous lessons, so you won't find it difficult to understand if you haven't done the previous part. This Thursday and this Sunday I'm starting the new lessons, coplanar forces. Can you do it another day other than Monday? Not sure about that because I have extra classes for 26 batch on Wednesday morning and Thursday morning, or Wednesday morning and Friday morning, I think. So I think these are the possible days for 27 batch. I have sessions for 26 batch on Friday morning and Wednesday morning, and most probably Thursday morning too. Okay. And I mean, like I usually utilize all the holidays. Like even last year, or year before, I can't remember. For Vesak also we did the class. But what we actually did was we planned a dansala in the evening. So, and we did the class in the morning. So it's not legally prohibited. We were planning the event in the morning. Let's try to do the same this year. Let's do the class in the morning and organize a dansala here in the evening. Let's try to do that. Okay. Question 8. Question 8. A particle of mass 100 grams. A particle of mass 100 grams is projected vertically upward. Okay, it's going up. Particle of 100 grams. 100 grams means 0.1 kilograms. 100 grams means 0.1 kilograms. It's 0.1, right? Yeah. Projected up with a velocity of 20. Calculate the kinetic energy and the potential energy of the particle at the following positions. In the projecting position, when the particle reaches the maximum height, when the particle reaches half of its maximum height. 1, 2, 3. Okay. Pay attention. Pay attention. What is the kinetic energy here? I'll take this as the potential energy 0 level. Pay attention everyone. Stop talking. I'll take this as the potential energy 0 level. So what is the kinetic energy here? Kinetic energy here would be, I'll write it like this. Yeah. Kinetic energy here would be half mv squared, half, what is the mass of the object? 0.1 kilograms. Mass of the object 0.1 kilograms. Velocity 20. 20 squared. So you get 20, right? And since this is the potential energy 0 level, potential energy is 0. Clear? Here, what is the answer? Oh no, the second one is this. Here, I can say this. Pay attention. Here, the kinetic energy will be 0, right? Here, the kinetic energy will be 0, right? Why? At the highest point, this goes and stops. Clear? At the highest point, this will stop. Clear? At the highest point, the object will stop. Clear? So velocity becomes 0. Okay? Velocity becomes 0. So definitely kinetic energy is 0. Then what is the potential energy at the highest point? Potential energy at the highest point is 20 joules. You don't have to do any calculation for that, right? Why? Why? Mechanical energy conservation. Mechanical energy is conserved. Here what was the total energy? 20 joules plus 0. Here the total energy is 20 joules plus 0. That means total mechanical energy is 20 joules. Clear? And the only external force you have here is gravitational force, right? Only external force you have is gravitational force. So here also the total energy should be 20 joules. Here also the total energy should be 20 joules. Clear? Total energy should be 20 joules always. Clear? And here, since the total energy is 20 joules, and this stops at the highest point, this stops. That means kinetic energy becomes 0. Then the potential energy is 20 joules, right? Potential energy is 20 joules. Clear? Clear? Ah. Then here, again you can tell potential energy is 10 joules and kinetic energy is 10 joules. Why? This is h. This is h, maximum height, and this is half of the maximum height, right? So if this is mgh, this will be mgh over 2. This is the maximum height h. Here, this is the half of the maximum height. Clear? Which is mgh over 2. That means if the potential energy here is 20 joules, mgh over 2 will be 10 joules, half of the potential energy. And since the total should be 20, remaining 10 should be here. Remaining 10 should be here. Clear? So you can directly go with energy equations. No need to go for motion equations or anything like that. Clear? Directly go with energy equations. Clear? And one of the main reasons for me to finish energy, work power energy today is, even if you're not getting work power energy for your term tests, working with work power energy is far more easier than working with working with motion equations. Okay, it's really easy to go with uh, energy equations rather than using motion equations. Okay, because see, now in this projectile, if you need to find the maximum height, what should you do? I mean, you know the maximum potential energy. For this projectile, if you need to find the maximum height, this is the potential energy, which means mgh. M is 0.1, G is 10, maximum height h equals 20 joules. See, you solve this and get the maximum height. Clear? Clear? In many questions, okay? In many questions, it's easy to work with energy rather than working with motion equations, okay? I'll show some examples, quickly finish writing this. Have you anything? Do you have anything to do after 2 p.m.? And the online students are also good. We started at around 100 and around 180 participants, Zoom and YouTube live. Still we have around 130 overall maybe. So yeah, so usually online people don't stay for that long. So it's good. I mean, it's understandable. It's much more difficult to stay online for 6 hours, right? Physical class, at least you have nothing left to do. If your parents pick you up or if you go home at 2, you have to stay here. But it's far more difficult when you have more options online. Even online students, like when you are working, keep your own working space separate. That means like specifically to go to online classes, keep a separate table if possible. Not distractions, nothing. Just like you come to a physical class and stay here, now you can't do anything else, right? You just come to the physical class and stay there. Just prepare a separate table to go for online classes. So when you sit on that chair, you will be mentally ready to go for a class. Okay? You will be mentally ready to go for a class. So if you are joining all the sessions online people, continuous online people, it's better to have your own place just for online classes, not to work. It's not your workplace, okay? Not to work, just for online classes. So with time, your brain will be used to that place. Then your brain will like figure out, okay, this is the place that this person go to classes, okay? So there will be less distractions. You will be mentally prepared when you sit on that chair to go for an online class. It's a very convenient thing to do, okay? If you are joining online long term. Okay. You just need your books there, a water bottle, and that's all. Okay. Not all the books, only the relevant books for this online class. Okay. It's a very convenient way to join online classes. Pay attention. I mean, previously, pay attention. Stop talking, everyone. Pay attention. Stop talking. Okay. I mean, initially, assume that this height is 4 meters. This is 60 degrees. You place something here. You release it at 0 velocity. What will be the velocity here? It's a lot of work, right? It's a lot of work. Acceleration g sine 30. Then apply motion equations from here to here. But now you just go down by 4 meters. So the potential energy you lose is mg h. H is 4. You just go down by 4 meters, right? Although it's in this direction, still vertically it's 4 meters, right? So you lose mgh, mg4 potential energy, which turns into your kinetic energy half mv squared, which turns into your kinetic energy half mv squared. Clear? M cancels out. V squared equals here 4. G means 10. You take 2 here. You get 80. V is square root 80. See? Like this, even when you have friction and everything, thinking like with relationship with energy would be really easy, especially for MCQs. Even if you're not getting work power energy for your term test, still no one cares how you get the answer in MCQs, right? I mean, since we have a weekly paper every week, that is another reason to do this. You can use many short methods on weekly papers using energy conservation, okay? Using energy conservation. Energy conservation makes everything easy. Assume, assume you have a friction here. Friction of maybe uh, friction of zero point 0.2 newtons. Still you can get the answer. Why? You lose mg4. You lose mg4 potential energy. Initially it was totally kinetic energy. Now the potential energy you lost converts into work against friction 2. This is the potential energy you release. This potential energy ideally should be converted into kinetic energy, right? But now you have kinetic energy and you are moving with a constant friction force of 0.2. So 0.2 into what is the distance you are going against the friction that you can get, right? L. See, 0.2 into L. Use all this, you get V. See? Okay. Lot of questions are really easy when you bring energy conservation in, right? Otherwise, you have to find the acceleration considering friction and weight all. Then you apply motion equations. It's a lot of work, right? Now it is just you lose mg for potential energy. Ideally, it converts into kinetic energy. Now it is kinetic energy plus work against friction. Work against friction. Friction, work against friction means Fx. Friction is 0.2 and this distance you can get using sin 60, right? You can find L. See, only one line you get the answers. Many questions are really easy when you consider energy, okay? When you consider energy. Will help you a lot in term tests, okay? I mean, next week, one of the main plans would be I'll do a bunch of questions like this, okay? I'll do a bunch of questions like this, connecting the previous theory points we already know with the new energy equations we learned, okay? Okay. So I'll quickly finish other theory points remaining. That's not much actually, would take only 10 minutes. Pay attention. Only few terms I have to define. Pay attention. Only few terms I have to define. Some you already know. What is power? What is power? Work over time. Pay attention. Stop talking, everyone. Pay attention. Pay attention. Work over time or energy over time. Work over time or energy over time. That means how fast you release energy, absorb energy, or do work. Rate of energy. Clear? This is power. There's another equation for power. When you have a constant force, when you have a constant force and ideally constant velocity, there's another equation for power. We usually use this equation to calculate the power of vehicles. Tell me, like, if the displacement of this object is x, what is the work done? What is the work done? F x. And if the time taken to go from here to here is capital T, you know that capital T equals x over v, right? Distance divided by velocity. Distance divided by velocity, you get time, right? Clear? So you can replace x by vt, velocity into time. So you get f velocity into time. Clear? Then what is power? Work over time. Power is work over time, which means F into Vt over the time spent. Clear? Then T and T cancels out. You get P equals Fv. You get P equals Fv. If a vehicle is moving under a constant force and a constant velocity, you can use P equals Fv equation to get the power of that. Clear? To get the power of that. P equals Fv. Clear? Then the next term is efficiency, which you already know. What is efficiency? You take a motor, an AC, a vehicle, or anything, even you, okay? You get some kind of a power in, but you don't do 100% work from that. You have a certain power out, right? That means if you provide 100 watt power, I mean this laptop, it's consuming I think 250 watt or something like that. Okay. Okay. And I don't know, it's lagging a bit today. A small delay, I don't know what is happening. I mean, I usually use Legions to do classes because they are really reliable and expensive. But now even Legions are lagging because I mean, we don't treat that well. I mean, I never service my laptop. And initially I thought like there are white color like around the fans of my laptop. like beneath that there's a net, right? In that net, everything is white. I thought initially that it was dust. No, it is due to overheating. It has, I think it's oxidization or something like that. I mean, they said that it's impossible that you do something like this for a legion, but I have done that. Anyways, so even the laptop, taking a power of 250 watt, taking a power of 250 watt. Uh, but it never produced 250 watt output, right? Maybe based on the requirement, maybe 100 watt, 200 watt. Clear? You never use 100% of energy you consume. Clear? Clear? That means if you use the 100% of energy, there can't be emissions. That means in a diesel power plant, there are some emissions, right? In a diesel power plant. Okay. If you were using diesel with 100% efficiency, there can't be any other emissions, right? All diesel should be converted into energy. Clear? But it's not happening. So every system is not efficient 100%. It takes a certain power in, but it outputs a certain power out into 100%. This is efficiency. Clear? This can be written using power or energy. Energy in, you take 1000 joules in, but you do a work equal to maybe 800 joules, like that. This is efficiency. What percentage of power you output from the power you get as the input, or what amount of work you do relative to the energy you consume for that. Clear? Okay, we don't have 100% efficient technologies yet. Okay, even our nuclear power plants are not 100% efficient. Clear? Solar panels around 20, 30, 25, 35. Okay. Actually, the diesel power plants kind of stuff are much more stable than, much more efficient than that at the moment. But the problem is carbon emissions, right? Okay. So this is efficiency. Yeah. This is the part like they have asked us to do. I mean, they have asked us to finish until this point in this lesson. Okay. I have added E equals mc squared to the end. It is not actually in the syllabus. Okay. But what you have to know is, if these sheets mention the time, I don't care. So maths, whether maths or bio is hard. I have no idea about bio. Okay. Okay. All I knew was I hate bio. I mean, after going for that medicine exhibition, after that for days, everything I eat, I saw that human part. So after that, I knew that I'm not going to be a doctor. That's how I that's how I went to be an engineer. I mean, you have everything in bottles. Why the hell they are supposed to be in the body, not in bottles? Okay. Uh, pay attention. Pay attention. Now, like nothing new here. Einstein figured this out. Stop talking, everyone. Last few minutes. Einstein said that no, energy is not conserved. Sometimes, stop talking, everyone. Sometimes mass can be converted into energy and energy can be converted into mass. Okay? Mass can be converted into energy and the energy can be converted into mass. There were multiple examples for that. We'll do that in the last lesson. Matter and radiation. There's a whole section about nuclear science. Okay? But the idea was, if you provide enough velocity to mass, it turns into energy. Okay? And in certain nuclear reactions, you lose some mass. That means ideally in chemistry, mass is constant. Ideally in chemistry, mass is constant. Ideally in physics, energy is constant. Okay? But actually, energy and mass is constant as a whole. That's the actual thing. Okay? Clear? Which means if you can, if the mass of this pencil is 200 grams, okay, if it is 200 grams, that means it is 0.2 kilograms, right? If you can destroy this at a nuclear level and convert this into energy, or if you can send this with a velocity equal to the velocity of light, this will be converted into energy. This will be converted into energy. What is C? Velocity of light, which is 3 into 10 to the power 8 squared. 3 into 10 to the power 8 squared. That means what Einstein said was, energy and mass are not two things. It's one single thing under two states. Okay? Because energy is moving really fast. So you don't see that as an object. Objects are not moving enough. Okay? So you don't see that as an energy. This is the same thing. Energy and mass is the same thing under two states. You can convert mass into energy and energy into mass. Clear? That is the idea. Okay. So this is not actually mentioned in this lesson. It's mentioned in the matter and radiation lesson, last lesson. But this is the rough idea. Okay. Here you can use this equation for the conversions. So there are a few questions remaining from exercise 7, exercise 6, and exercise 5. Next week I'll finish these questions, bring some new questions that to show you how to use energy equations to make your life easy for other questions. And in the remaining time, let's try to do some term test papers too, okay? So next Monday and Tuesday, same plan will continue. And this Thursday, we are starting the new lesson, coplanar forces. Let's try to finish that too before the term tests of the people, okay? Thank you. And to get the tunes delivered and to join groups or anything, contact this number, 070-154-6825. Pass the message. Tomorrow also we are doing the same session, okay? But mainly in Sinhala, but Sinhala and English mixed. Thank you.